your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone and welcome to a new season of our live days. My name is Benedict. I'm the DevRel community manager here at WeAreDevelopers, and I'm so glad that you all made it today. As you can see, we not only have a studio, not only that, we also arranged for 5 awesome talks today. Because what would be a better way to start off the new season of the WeAreDevelopers Live Days than with one of the classics? I'm talking about Java, of course. During the talks, feel free to interact with each other in the chat to your right. If you have questions, submit them in the area. But as always, be nice to each other and respect each other. We have a code of conduct. Here's a short video about it. And right back to Java. Our first 2 guests, Michael and Philip, are both senior full-stack software engineers at the Austrian Federal Computing Center. So they certainly know what they're talking about. Welcome, Philip and Michael.
Hello, thanks for being here.
Hello.
Hello you two. How are you doing?
Fine.
Fine. How are you doing, Benedict?
Oh, I'm fine too. Thanks for asking. So what are we going to learn from you two today?
So today we want to talk about our journey with Spring Boot, especially in our microservice architecture. And yeah, we are happy that we are here today and we are looking forward to our talk.
Okay, then I would say without further ado, stage is yours.
Thank you, Benedict.
Thank you very much for your introduction. Yes, as already mentioned, our talk is about microservices, and we are using microservices in our projects for over 2 years now. And yeah, when we, for us or for our teams, it was completely new to adopt microservice architecture. And so, of course, we trapped into many pitfalls, or we faced a lot of challenges and complexities we didn't expect before. But we also learned a lot and gained many new insights. And yeah, some time ago, we stumbled upon an article from Stan Pittet. Stan is a product manager at Atlassian. And one of his statements in this article is that running microservices is not a sprint. And when we look back at our microservice journey, we totally agree with Stan. Why we do that, that's exactly what we are going to discuss in the upcoming session. So before we dive into the microservice architecture, let's briefly discuss our architecture goals. What do we expect from our architecture? First and probably most important one is the so-called open-closed principle. We expect our architecture to be open for extensions and closed for modifications, meaning that if we want to add a new part, that should be able without having to modifying or changing the existing parts of our system. If something breaks, if something goes down, our system should recover quickly. Our system should be fault tolerance. And the third goal, also a very important one, is technology diversity. Of course, we are heavily relying on Java in our department, but we want our architecture to give us the freedom to choose independent technologies for developing different parts of our system. And since we're also getting constantly new team members and also new teams, we also want to have the ability that multiple teams can build independent parts of our system, and then brings us also to a next point. For that, we also need independent builds and independent test execution so that we can choose. We just want to trigger a build or trigger the test execution for a small part of our system rather than for the entire system. And of course, we should be able, our architecture should give us the ability that we can deploy or redeploy just an individual part of our system. As already said, we are heavily relying on Java and also on Spring Boot, especially Spring. Each of our service or product is a Spring Boot service, a Spring Boot application, meaning that we create a self-contained jar file that contains the application code as well as the service container responsible for executing that code. So if we just execute the single jar file, we will have up our server and our application running. For managing our dependencies and plugins, we are using Maven, and we are also following the design by contract approach. So we specify our APIs within a Swagger file, and based on this file, we generate API definitions and also client code. I'm sure most of you already heard about microservices. For those who are not so familiar with this topic, let's briefly discuss the main or the core principles of this architecture. In a traditional or in a free-tier layer, we have a presentation layer, a persistence layer where we have all of our data stored. The second one is the business layer, consisting of our business logic, responsible, for instance, for time calculations, fetching data, aggregating data, etc. And of course, we want to expose our data, so we need a presentation layer. And what then microservice architecture does is to decompose the business layer and the persistence layer into small parts, the so-called microservices, and each microservice has a small set of responsibilities and also its own data store. That enables us to work independently on different services at the same time, so we can install multiple teams and they can work together on a huge system without having impacts on each other. And also we are able to just build a single services on its own to trigger the test execution just for an individual service rather than for the entire system. And this architecture gives us the ability to deploy a new version just of a single service, or to scale up just a single service if we notice there is some bottleneck in the business layer. And of course, one of the most important things, we can add a new service without having to modify existing services. What happens if one service goes down or is unable to fulfill its service? Typically, that shouldn't have too much impact on the other service, but it can be the case. So let's briefly revisit our goals. As already said, we are clearly covering the open-closed principle by using a microservice architecture. We can freely choose our technology for building individual services. And we have already talked about it. We can independently develop and maintain our services, including starting individual independent builds and test execution, and we can deploy or redeploy just a single service rather than the whole system. Resilience and fault tolerance is a topic on its own. For now, it's sufficient to know that we can cover this topic to some extent, but we will more talk about in the second part of the presentation. For now, let's talk about our journey. So when we started with microservices, we had a situation similar as presented on the slide. So let's suppose we have 3 services, all written in Java, and service A defines some interface, and services B and C extend this interface. And if we have only a small set of services, it might seem that there are no big problems with this approach. But if we suppose, or if we change something in our interface, let's say we change a method name or add a new method, then it may be the case that we break the builds of B and C. And that clearly contradicts to our goals of independent development and independent builds. We did the same also with our Swagger definition, so that the initial idea was to share DDOs, and that's clearly a bad idea. For instance, if you have multiple services with 1 or 2 services, at the first glance it seems okay, but if your architecture grows, there will be more tight coupling between your services, and if you change a service and 3 other services break, that's not a good idea. The second pitfall we want to talk about relates to Maven inheritance. We had a shared repository where we placed a parent POM, and in this POM file we specified all the versions of our dependencies and Maven plugins, and all of our services inherited from this POM file, so that each service includes the same dependency versions and plugin versions. And so what happens if we do a Spring Boot update, if we increase the version in our parent POM? Then for all services inherited from this POM, they will include the same new version 2.6.4. And we all know it from updates. There can be some misbehavior, for instance, at runtime or something can be broken if we do this update. And with this setting, we have to update or upgrade all of our services at once, because all of our services inherit from the parent POM. It would be better to start, for instance, with service A, and if this goes well, to go over to service B until we have updated all of our services. So in a big setting where we have, let's say, 100 services, it's a bad idea to centrally manage dependency and plugin versions. This approach clearly contradicts to our technology, a goal of technology diversity. Of course, we write all of our services in Java, but at least we want our services to give them the freedom to choose their own dependency versions, because it can also be the case that a particular service needs a specific version because there are some compatibility issues with another library, etc. Yeah. And of course, we don't want to have some situation where we change something in the parent POM and possibly 3 other services break. That clearly contradicts our goals of an independent build and development. So as a takeaway from our first or early day pitfalls, we think that's very important to treat every service as it would be written in a different language, even if you write a service all in the same language as in our case. At the first glance, it seems to be obvious that trapping into this pitfall is, it seems to be obvious that we should not do that. But if you're in a stressful situation, if you're running out of time, running out of budget, you may be tempted to go the easy way, just to share your classes, you share your interfaces between your services. And in a small setting, it's maybe not a big problem, but if your system grows and you install a tight coupling between the services, it will be very, very much effort to decouple your services at some point in time. But sharing code isn't bad at all. How about shared libraries? In many projects, or nearly in all projects, we will have some custom libraries for common purposes, such as for time calculations, for caching mechanisms, providing functionality that is independent from our services. And it's completely okay to share this code, but we think a good strategy is to outsource these libraries and in a separate repository, and to introduce a versioning on it, so that each service can decide which library and which version of this library should be included. Versioning should be also a topic when it comes to designing our microservices. So let's suppose in our architecture we have 4 services, and of course in such a distributed system we need to have some inter-service communication in place. It doesn't matter whether it's an asynchronous communication via message broker and synchronous communication via HTTP calls. For now, it's just important to know there are some data flows between our services. For instance, on our slide, we have service A, and data flows are going from A to services B, C, and D. And let's suppose or for each data flow, we need some kind of data format. And let's suppose we, on service A, we change our data format and just drop a field or rename a field. So it can happen that services B, C, and D are no longer be able to process that format. Yeah? And that brings us to the topic of versioning. So it's always a good idea to introduce versions as early as possible. If you have just a small set of services, you may have a good overview of your dependencies or inter-service dependencies. So if you drop a field, you will know, okay, that doesn't matter for other services, you will not break something. But if your architecture grows, it becomes more difficult to keep an overview. So, and it's a good advice to just introduce versions and stay backwards compatible as long as possible. Of course, at some point of time, you will have to introduce breaking changes, such as to remove an deprecated field. And that brings us to a next challenge. How do you communicate such breaking changes? How do you know who depends on your service, who calls, which system calls on your service, which teams are responsible for that services? And that's also a matter of communication. Yeah. Versioning is a topic on its own, so we won't go deeper into this topic or dive deeper into this topic because otherwise we would run out of time. But there are great talks, there are great blog posts out there. For now, it's sufficient to just be sure that when we adopt the microservice architecture, we should think about versioning as early as possible. When we keep talking about inter-service communication, there's also another situation we encountered during our journey. Let's say we have two services and two communication channels between these services. The first one is just simple HTTP call. So data objects flow from A to service B via HTTP and also via a message broker. So why is this a problem? What can go wrong in this setting? For service B, there are two ways for messages for data objects to enter the service B. One via the HTTP and one via the message broker. So we also need two converters for converting the HTTP response into the local model of service B, and as well as converting the, for instance, JMS messages into the local model of service B. So we have two converters for converting external data formats into the internal model of service B. And we had a situation where we should introduce or implement some kind of anonymization. And so if a Boolean flag is true, we should anonymize some fields. And we did it only for the HTTP channel. So if we fetch data object from another service via HTTP, anonymization was fine. But if we received, or if our service received messages or data objects via a message broker, anonymization did not happen because we forgot to implement that. So it's multiple entry points for data objects on a single service also make maintainability more difficult. So it's a good practice, at least we believe it is a good practice, to have one single entry point for data objects to enter a service. That doesn't mean that that you shouldn't have multiple communication channels in place, but there should be only one way for entire data objects to enter a service. So in our example, it's completely fine if we use a message broker or provides a message broker to give service A the ability to send a notification to service B that there are some data available, on service B fetches the entire data objects via HTTP. In these settings, we would have two communication channels in place, but only one conversion, only one entry point for data objects to enter service B. If we again take a look at our architecture goals, and if we follow such simple advices, or at a first glance simple advices, such as that we should reduce our coupling between services, and then we clearly see that we covering nearly almost of all of our goals except resilience and fault tolerance. And this is exactly the point where I will hand over to my colleague Michael, and he will us tell more about the topic.
Okay, thank you, Philip. I will now proceed with our second part of this presentation, where resilience and fault tolerance is the main topic. One moment. Okay, sorry, does it work now? Okay, perfect. So yeah, I'm talking about resilience and fault tolerance. Resilience means to recover quickly from difficulties, and fault tolerance refers to the ability of the system to continue to work without interruptions when one or more components fail. So, okay. Sorry. Sorry. So, does this work better? Sorry, we have a small problem with our microphone. Does the microphone work now? Yes? Perfect. Okay. I hope everybody can hear me now. Okay, yeah, let's talk about resilience and fault tolerance. As we heard from Philip, coupling is an important aspect when it comes to microservice architecture. And I want to talk about temporal coupling, which is a kind of coupling where code is dependent on time in some way. There are different forms of temporal coupling, but today I want to focus on temporal coupling, which results when there are, for example, RESTful API calls in your system. So here you are coupled to this RESTful API, which can harm or at least make things difficult for your desired failure tolerance. So in this example here, we have a house, which consists of different parts. And in our example, these are 4 parts. And every part of this house is dependent on a service, and therefore it is coupled with it. For example, within a RESTful API. So now what happens if one service fails or is not accessible? In our example here, the left top roof service will fail, and due to this, half of the house does not work properly or has some issues. So if we want to have a system architecture which is failure tolerant, we need to address such issues and such scenarios, and we need to find solutions or measures for that. So in the next slides, I want to talk about such solutions, for example, backup strategies, caching, redundancy through scaling, and also asynchronous communication. At least, last, I want to mention that you do not need to apply all of these solutions or measures. In some use cases, also one action can be sufficient to reach a certain amount of failure tolerance. So now I want to talk about backup strategies. This is one possible strategy to increase your failure tolerance. For example, it is possible to for your feature to show default values if the needed service is currently not available. It is also possible to disable only the feature which is currently not available. So the rest of your features are still working properly, and not the whole application is down. For example, if you operate a news platform and there is a posting service of this platform, and this posting service is down, it is better that only this part of the application or the product is down or disabled, and the end users can still access the news platform to read news or access other information. Yeah, basically it comes to that if you apply backup strategies, you prioritize your features regarding your importance. And I have here a second example, which you can see on the slide. For example, the Google search engine. There is this well-known autocomplete feature, which was introduced years ago. And if this feature does not work properly or is not available due to different reasons, it would be useful that only the autocomplete feature does not work and users can still access the search engine, but without the autocomplete feature. So another possibility to not only to reduce or to increase failure tolerance and resilience, but also to increase your performance is caching. It is easy to implement and this is also a fast solution. In this example, there are two services, A and B, which are connected with an synchronous HTTP call. So service A needs information from service B via a synchronous HTTP call. Instead of calling service B for every single request, it is possible to create a cache for this request, which means that you have a local data storage, for example, a database or another form of storage, where this data is stored locally. So in this case, now the cache is asked beforehand for the desired information, and only if the item is not in the cache or is evicted by the cache, you need to call the service B and get the information. So in our products, we are using Google Guava Cache. It's a very simple solution and it has a great Java Spring Boot integration and is also very super easy to handle. Of course, it is also important to implement or to configure meaningful eviction properties. For example, you can evict your cache by time, for example, after 10 seconds, or by size or weight, for example, store only 1,000 elements. You also need to care about data changes or how often the data changes in your service B. Because if the data changes every second and you store your information in your cache 24 hours, you get the requesters from service A gets old information, and in most cases, this is not what you want. Also, you should think about your message broker consumers, where you probably get new data from other service. Also, in this case, you need to evict your cache. The next thing I want to talk about is redundancies through scaling. So if service A is tightly coupled to service B, again, via a synchronous HTTP call, it's possible to ensure failure tolerance also with an auto-scaling feature or a failover feature from a platform as a service like Kubernetes. If you use such a platform like Kubernetes, you should implement, of course, monitoring and also meaningful readiness and health checks. For example, Spring Boot Actuator offers Kubernetes readiness and liveness checks, which are very useful for your Kubernetes deployment. So in case of a faulty service B, which you can see here with the yellow sign, Kubernetes observes this immediately through the health checks, which we get from our Spring Boot Actuator. And Kubernetes says, okay, I need a new instance for this service B, and starts this new instance. In Kubernetes terminology, it's a new pod. And therefore, service E can access service B without interruption, or at least only with a short interruption. So what is really important is for your auto-scaling feature, which is, of course, offered by Kubernetes, and many products heavily rely on them, is that your services are totally stateless. Because if there is a state in your application, you cannot scale this with multiple instances. Next, or the last measure I want to talk about to increase failure tolerance is asynchronous communication. Philip introduced before a lot of things about that, and I want to go a little bit more deeper because we think that this is a really important topic, and we had a lot of pitfalls within our journey. So we have here service A, which publish data to the message broker, and we have service B and C, which subscribes to this topic. So if there is a problem in service A, there is, you can see it here, there is of course no problem with service B and C because we are not tightly coupled, we are loose coupled, and therefore the only problem is that no new data comes into the message broker, and therefore no new data comes into service B and C. So therefore this communication pattern is loose coupled. You have a higher availability, but there are a few challenges which you have to face, because you need to think about loss of messages. You need to think about a good redelivering mechanism. You need to think about a dead letter queue for messages which cannot be processed at all. And you need to think about versioning, and also an important topic also discussed from Philip. Because you need to think about if you have messages in your dead letter queue and you want to redeliver such messages, probably you have a totally old version of this message, and your consumers, your subscribers cannot process this message anymore. Okay, now I want to give a brief comparison between synchronous and asynchronous communication in order to show the advantages and disadvantages. So the first property we want to discuss is development and testing. This is, of course, a little bit easier in a synchronous environment, because in an asynchronous environment, you need to think about error handling, unresponsive, event processors, and so on. Also testing, especially integration testing, is much more problematic or complex. The second thing is the instant feedback. Of course, if you're in a synchronous environment, you get the instant feedback, and in an asynchronous environment, you only follow the pattern fire and forget, and you don't know if your message can be processed successfully by all of your subscribers. As I said before, monitoring is a challenging and important task in an asynchronous communication environment, because you need to care about redelivery, dead letter queues, and so on, which is not necessary in a synchronous environment. So now we come to the advantages of an asynchronous environment. For example, you're not time coupled to your other services, and also the fault tolerance is much better than is in a synchronous environment, as I showed you in the last slides. When it comes to propagation of events, this is usually done in an asynchronous manner, because if you think about notification events or something like similar to that, you don't even know how many subscribers do you have or how many subscribers rely on your events. But there are, of course, also other use cases where synchronous events, for example, triggers, or asynchronous events, for example, triggers a synchronous action. For example, as Philip said before, you get the asynchronous event, and then you fetch the data from your service via a synchronous call. Which communication method you choose and how to combine them is, of course, not a trivial task, and it's a challenging task. And so you often have to say, it depends. It depends on your use case, it depends on your requirements, and also your system boundaries. So let's have a last look on our goal slide. Now we can see a lot of green ticks, which is, of course, very good. And we also faced now the issue with resilience and fault tolerance. And I give you a few different solutions or measures to face this goal and to fulfill this goal. So our team, where Philip and me is working, we are doing microservice for over 2 years now. And we have learned a lot in this time period. So as Philip said in his first slide, running microservice is not a sprint. And I, of course, can also totally agree with that. We think that it's important to define your architectural goals, as you see with our goal slide, which we talked about before. And we want to reach with our microservice architecture. Also, it should be possible to redefine these goals and to adapt these goals if this needed. And therefore, a key takeaway from today's talk should be that you need to constantly improve and further develop your microservice architecture. And this comes to the second key takeaway. Designing and running microservice is an iterative task, and you need an iterative mindset, not only within your developer team, but also for all the other stakeholders, including your customers. So it's an ongoing process with lots of changes and refactoring on the way, and therefore your system and also your team should be open-minded, open for changes, and also courageous for changes. So due to the fact that the services are usually small and independent, such changes are more easily possible. And that's why we think the microservice pattern is a good pattern to drive innovation and to make things better. Also, I want to mention that it is better to make a change in one service and try this change out. And if the change is successful, you can roll it out to all your other services. So our today's talks focused on different aspects in microservice architecture, but there are a lot of other challenges and a lot of other topics which we were not addressing today. For example, it is really important to think about how you cut your services, how small or big your services are. And there is this famous topic, domain-driven design, which we think about this is a very good design pattern, and you should heavily rely on that. Also, the organizational aspects and communication we did not mention in today's talks, but of course, as we are all humans, it's very important to face this topic, because if you work in a probably distributed team, communication and organizational aspects are very important. And last but not least, our infrastructure and our used frameworks should be suitable for our microservice architecture. For example, a platform as a service like Kubernetes gives you a lot of out-of-the-box features to reach your architectural goals. And it is also a good advice to basically automate everything, including your infrastructure. For example, GitOps can help you to automate your deployments, your infrastructure, and basically all your repeatable tasks, which probably you are doing right now manually. With GitOps, you can automate this kind of things. So we want to close our today's presentation with a cite from Sam Newman about building microservices. He says, "Can you make a change to a service and deploy it by itself without changing anything else?" So if you can answer this question already with yes, you are on a pretty good track with your microservice architecture. And yeah, it was a pleasure for Philip and me today. We thank a lot for your attention. And now Philip and me, we would be happy to answer your questions and to discuss a little bit about our journey with microservices. Thank you.
Hey, you two. Thanks for the awesome talk. Very fascinating topic. We also got some questions submitted. If you're ready, we could start right away.
Yes.
Yeah, sure.
Perfect. Yeah, the first one would be, what message broker implementation best fits your requirements? Kafka, Pulsar, JMS, or maybe another?
Okay, yeah, probably I will take this question. Yes, when we started to searching for message broker technology, of course we came to Kafka, and or also we had a look on RabbitMQ. But in our company there is a proprietary message broker called TIBCO, in which is supported from our company, and therefore we used this message broker, but it's a JMS message broker like every JMS broker else. So we rely only on the JMS features which we get from Java. So yeah, but it would also be interesting to get some insights from a Kafka environment.
It's always good to try something new.
Yes.
So we got another question. Replacing sync communication with async communication, how is this going to work?
Yeah, first of all, you should think about, is it necessary to replace synchronous communication channels through asynchronous communication channels? And also, is this topic also relates to data redundancy. So we have the case where we have to extract data from a legacy system, and that is a perfect fit for an asynchronous communication channel where we have a job that's fetching the data from the legacy database and submitting the messages to our TIBCO message broker. And eventually our subscriber will receive this data and transform them into their local data models and further process them. Or we have also a service that has an Elasticsearch engine and also to include submits the new messages to the local index. So first of all, we always think about, is it necessary, because it introduces more overheads than a synchronous call. And what we do is, when we replace such a communication channel, we use both in parallel, introduce a new queue, a new topic, and a consumer. On the other side, on the services that's interested in this particular data objects, and you can, as a service that holds the data, you can provide both channels. So if there is an old version of a service that still relies on the synchronous channel, so that this service can fetch the data in a synchronous way, and also for new version, our service provides or publish new events or data objects via our message broker, so that both you should first, when you switch, you should support both on the source level, on the source service. And if you're sure that all other services are consuming your data via an asynchronous channel, you can turn off the synchronous channel, for instance, your APIs. Because as we already talked about, we shouldn't maintain two channels for streaming data to another service, because you have to implement two converters, and you have also you need to test them, you need to write automated tests. So we think it's best to do this parallel way only until you are sure that other services are now able to consume your messages via a message broker.
Okay, hope that answers your question. As we got some more, for example, what was your experience with metrics and monitoring in microservices?
Yes, we heavily, so this is also a journey right now. We are not finished yet, but nowadays we rely on Spring Boot actuator health checks. And for example, we also use these health checks to monitor, for example, if our message broker consumers work properly. And yes, I think our monitoring is based on our Spring Boot actuator checks. And then we have also alerts based on log files, which we are doing with Splunk. It's a log file. How to say, like similar to Elasticsearch, but the special use case in Splunk is log files.
Yeah, exactly. And also interesting tool is Zabbix. So there's also a monitoring for observing our topics and queues in TIBCO. If there are too many messages on a dead letter queue, for instance, our operations team will notice that and to inform us, so that someone takes a look and investigates why are there messages that can't be processed or consumed by a particular service. And that's also an overhead that you get if you introduce asynchronous communication, because you also need to establish a monitoring for your queues, topics, and of course your message broker.
So, for example, we start on the first days with just not a good monitoring at all, and now we have interfaces to query the message, the letter queues. We have also the possibility to take a message from the dead letter queue and republish it on a different queue. And yeah, we also have plans to more improve this interfaces, because it makes things much easier for the operators if you have automated task, and manual is better than automated is better than manual.
Yes, and another question. How did you manage shared domain classes across services? That is, if you had some in the first place.
Yeah, we tried to almost remove all of them, so that each service has their own data model, and of course you have to do things twice, 3 times, or 4 times. With one exceptions, we have some objects, for instance, geolocations. We know that we will also have in 1, 2, 3 years only 2 properties, latitude and longitude, for instance. So if we are really sure that this object won't change, or the objects won't diverge between services, we think about reusing an object, but it's really an exception. As for instance, at the beginning, it seems an easy way, a good approach to share entities, domain models between services, but it can be the case that the models of each services diverge. For instance, you have fields in service A and you don't need it, or another service changes something at the model, and service B and C get broken. So we thrive toward this. We really want to remove them, and of course we have to implement something more than one time, but we think in the long run it's a good idea to share as less as possible.
I think for every developer, if you do something twice, or if you duplicate code, you don't want to do this in the first place, and we don't do this in the first place. But there are good reasons and good scenarios and use cases where this is necessary and where this is totally okay, especially in a microservice architecture.
All right, one more question. Some people wanted to know if there is any possibility to receive your presentation slides. Maybe you have a company social media or something where you can upload them. Would it be possible?
Yeah, or you can also drop us an email and we would send out the slide. But I think we will.
I think it is also possible to upload it to some share or something like that. Yes.
Yeah, of course.
Would be.
And I think this talk would be available after. And I think this talk would be available after the streaming, isn't it?
Yes, it will be uploaded to our live section. All right. During your talk and also during the questions, you talked a bit about your company. Maybe you want to share with me and the audience a bit more. How's your work day there as full stack software developers?
Yes, so we are here in the Austrian Federal Computing Center in Vienna. And Philip and me, we are working for the Austrian Employment Services. So we are currently in projects to modernize their IT services. And in the last 2 years, we are making a job platform where you can search for a new job. And we use their Elasticsearch and some other cool technologies for searching jobs. And we are also working on internal products for the Austrian Employment Services. And yeah, since the pandemic, the typical workday changed a little bit because before COVID we were at least nearly every day in the office, but nowadays it's like especially in our team, we are in the office for the sprint planning. So we had 2-week sprints, and so we are here every 2 weeks. And of course, for refinement meetings or meetings with the customers, we are also often in the office in Vienna. You want to add something?
Yeah, we also work on other projects or other teams, for instance, for the Ministry of Finance or Ministry of Justice. So we are mainly building software products for the public sector. And another huge area is also to provide servers and to maintain them as a software development and to provide the server infrastructure for the public sector.
For example, we are using Red Hat OpenShift as a platform, as a service, which is deployed here in Vienna.
All right. So, and if someone from the audience wants to join your team, we've added a banner on this live page. You can just click on it and get some more information about it. So, and maybe the last question from the audience. When you use Splunk for logging, what's your experience with tracking on a request across services, and how are their logs collected?
Okay, I take the second part of the question. Probably, Philip, you're talking about tracing, but I think you're a little bit more in tracing. Yes, we are using Splunk for our log files, and the log files are collected for our VMs or virtual machines where we run Linux. The log files are collected with I don't know exactly. It's a program that collects these logs. And in our Red Hat OpenShift environment, the logs are collected with FluentD. And there is a heavy forwarder. I'm not the expert in this, but yeah, FluentD I think is the buzzword for collecting logs.
Yeah, and in Splunk, so you can write your own queries, and you can choose which data source you want to include. For instance, you want the log files from free services, and from an implementation perspective, it's important to log some ID to implement some kind of tracing, so that one service uses the same idea in between for interaction between other classes and also between inter-service communication. We are now migrating to OpenShift, and currently we are in touch with Jaeger that injects some ID, and all services along this path will use the same ID and also include this ID in their logs. And in Splunk, you can aggregate this, or also in an Jaeger UI. There are many other tools, but if we do some analysis, we will include these log sources in Splunk, and then you can search for a particular ID, and all log statements that include this tracing ID will show up, and you can do further analysis. You can reorder them. You can define another time range if you're searching for a particular bug or whatever. So it's pretty pretty exciting to work with Splunk, and it also provides a lot of features. You can also introduce or implement some kind of alerts. So if there is anything wrong, if a particular failure occurs, that you can implement the configuration such that automatically a mail is sent to your operations team or whatever. So it's really, really a cool tool.
All right, let me withdraw my last statement about last question because we got some more. People are very active today in the chat. I really like to see that. So more of a general question. What are the best ways for developers to keep up with changing technologies? So maybe you have some examples for like more information sources that you use yourself?
Yes, I think that's a interesting topic because so the technology changes very much. So 10 years ago, there were no Kubernetes and stuff like that. And today, everything is containerized, and there are lots of other frameworks, service mesh, and all stuff like that. And there are, of course, the Udemy courses, which we were allowed in our company to take. I think that they are very good. And I think it's also very good to have a look at different conferences, for example, the WeAreDevelopers, because there you get there you see, because if you only it's interesting because it leads us to our talk, which was in January, because if you use a technology and you Google them and you don't really know how production ready is this technology, or how many people rely on that, or how big is the audience which are on this technology. And if you are on a conference, or if you are or if you just had a look in the GitHub page, you can a little bit see how many people interact with this technology, and that is a good sign if this project is well maintained and promising for the future.
Yeah, I think conferences are a real great opportunity to get an overview, and maybe, for example, attend it at the KubeCon. It's a conference for cloud native technologies, and it's a field we are not really deep into it. So we wanted to get an overview about the new technologies, and also how do the community assess their projects, because there are so many projects out there, and this only in a particular field. And I think it's a good idea to get in touch with other people, with other companies. Are there any companies out there that have already a tool in place in their production system, or what are their experiences? And I think communities, conferences, and get-together events and such like that are really great opportunity to get in a discussion with other developers and engineers.
Thank you for those personal insights of yours. Another more general question would be, according to you, at what age can children be introduced to programming?
I don't know if we are the correct.
I think it depends on the language. I think there are programming language designed in particular for children, and also programming assignments, or some assignments at an easier level for people, or especially children who want to start with programming. I think it's a good idea to look at the web. I think there is a programming language for children or for young students, but unfortunately I can't remember the name. But it should be an easy language. Maybe C or C++ is not a good option for starting to learn a programming language. Maybe a language that is more abstract, or has more tools, and you as a programmer can more think of your business logic rather than maybe memory consumption or freeing your memory. But it's maybe also a good starting point may be web development.
Yes.
So to start with simple pages, maybe a little guest book or something like that, and at some point of time you can try out another language, maybe start at one area. For instance, start with front-end programming, and if you're fit in that area, if you want to try something out, start at the back-end programming and not at all at once. I think it's that's. But for children, I think there are some languages out there.
All right. Michael, Philip, thanks for being here. Thanks for the awesome talk and the very detailed insights. I hope you have a great day and see you next time.
Thank you, Benedict.
Thank you very much.
Ciao,
Thanks, bye. Ciao. So, and we jump into 20-second break before the next talk. Stay tuned.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone. So, after this first interesting talk, our second guest, Christian, who is a freelancer, full-stack developer, with over 10 years of experience in writing software, I think he's more than prepared for his talk. Welcome, Christian.
Thank you. Thank you for your introduction. In the next 45 minutes, I'd like to show you a bit about, in quotes, new programming language called Kotlin. But prior to that, I want to go back to what the previous presenter said. One really cool programming language for children is Scratch. They can use it even from the first class to the sixth. It's really cool. I've also used it prior. But let's start with my talk. So first, thank you already for the introduction. My name is Christian. I'm a senior freelance full stack developer, and I write mainly my code in Java and with Spring Boot and Angular, TypeScript, and JavaScript. So, but that's enough for me. Let's start with the topic. So, what even is Kotlin? Well, Kotlin is a multi-paradigm language which is compiles to the JVM, to JavaScript, but also to native. So you can create applications for almost every platform. It's an open source programming language which was created in 2016. The first version was released then, and then it's developed by the open source community and by JetBrains. So it's already a mature language, 6 years old, and is used in many different projects. But why should you as a Java developer use Kotlin? Well, Java really likes Kotlin and Kotlin really likes Java, because in Kotlin you can just access every Java library you know. So you can, for example, use Spring Boot with Kotlin, you can use all your Apache libraries with Kotlin, you can use Maven, but you can also just, for example, add one Kotlin file in your existing Java project, and by using Kotlin compiler, then you can just access Java code from your Kotlin code and vice versa. So if, for example, you can access all the math libraries and the Apache libraries inside Kotlin by using the Java libraries. I will show you that later in the talk. But in my opinion, that's really cool, because you do not have to decide if you want to use Java or Kotlin. You can use them together. So what the other speakers already said, well, you want to have something which is already in production. So who does it live? Who does it run in production? So first, for Android, that's the main programming language used. So prior to Kotlin, Java was the main programming language to create Angular applications, but Google decided that they want to use Kotlin as the main programming language, and nowadays you use mainly Kotlin to program Android applications. Also, companies like Slack or Google use Kotlin, and I'm from Switzerland, so I've worked in banks and in insurance companies which also use them. For example, Zurich Cantonal Bank uses Kotlin for their backend development, so they have Spring Boot and use Kotlin there instead of Java. Also, the Helsana insurance company, a big insurance company in Switzerland, also uses it for their backend, for the customer portal. So also they use it with Spring Cloud, so with Spring API Gateway, and so on. So it really uses many different. It's really used in a variety of production-ready software, and which is already used since years in production. So yeah, let's just switch right into the code. So as you can see, we are in IntelliJ. So at the top, we have a Java file, a simple Java file, and at the bottom, we have a so-called kotlin.kts file. Kotlin supports two different types of file types. The first one is the .kt file, which is the equivalent to the .java file. But the KTS file has one important difference. First, it gets compiled in memory. And the second cool thing, especially for presentation purposes, is that you can write code right at the top levels. You do not have to wrap it inside a function, like in a main function. So let me just show you how that works. So let's say we have our Java class at the top here, and we want to create a hello world. So we create the main function and we create hello world. Now, because if you were in a Kotlin file, in a .kt file, we would use fun main and then run println hello world. As you can see, you do not have to put your functions inside a class because Kotlin supports by default top level functions. So you do not have to create a wrapper class around your Java, around your functions, but you can write them right inside your .kt files and you can access them from outside. So, but because we're in a .kts file, we do not have to use the main, we can just use hello world like that. And because we are in a worksheet, that's something IntelliJ provides, you can see at the right side, we get the value emitted immediately. So that's really cool for demonstration or for testing some stuff out. So let's get started with some type inference. How do we create variables in Kotlin? Well, let's say we want to create a variable. We use the keyword var, and then the name of our variable and the type and hello, and let's say call it world. Now here at the bottom, we want to concatenate it and we want to print it out. As you can see, it prints out hello world. Now, what we can do, because Kotlin knows type inference, is we can omit this type right here. And as you can see, Kotlin still knows that this has to be a string. So we cannot just assign a 1 to it because at compile type, we still have our valid JVM bytecode, which has the type compiled into it. So we cannot change it to an integer, for example. That doesn't work. But what we could do is we could reassign it. Well, how do we want to make our variable final to not be able to change it? Well, you can just use val instead of var, and now you cannot change the variable anymore. So instead of using final, like you would in Java or Java 11 with final var, you just use val. So the next thing we can already see is how we can work with strings, because here at the bottom, IntelliJ says as well, we can change that to make it more concise. So let's just remove that concatenation right there and just use string templates like that. We can access our variable right inside of our string template. We can go even further. We can, for example, access the length by using curly braces around it. So that way we can put our variables right inside our string template and we do not have to change and do not have to concatenate it. So let's switch that back to the name. And let's, for example, say we want to create a multi-line string. How can we do that? Well, we just write 3 quotes at the start and 3 quotes at the end. And then we can do things like world and it's Wednesday, for example. And now let's switch it to show it in split view, because that way you can see the line breaks. As you can see now, we have hello world, it's Wednesday. And now what we often don't want is this indentation right here, because this indentation you see right here is also what we see on the left side. But what can we do to avoid that? Well, we can just use the trim margin function and then add at the front of it this prefix, and as you now can see, the prefix got removed, and we have it like we wanted it to look like in our print line statement. If you want to use it otherwise, if you, for example, want to use it with the ampersand, then you can do that by just using ampersand as a margin prefix. As you can see, this also works. So that way you can write multi-line codes without having to concatenate it and use this \n to check to create a new line. That way it's really intuitive, in my opinion. So let's say instead of doing some strings, let's see how Kotlin is different from Java in kind of expressions and statements. Let's say we have our variable here, our name, and we have our string. We say this is an empty string, and we want to assign it to the result of an if-else statement. We have if, for example, true here. If it's true, then return it's true, or else set, well, it's false. So as you can see, this works. We get that printed out. Let me switch that up to be full screen again. It returns it's true right here. Now the problem is this variable has to be mutable to fulfill that, to be able to be reassigned. But Kotlin doesn't want you to use a variable, a var, whatever possible. So Kotlin made the decision to switch the if statement to also be an expression. So what you can do instead is we just remove this assignment and this name assignment and this too. And as you can see now, even if you recompile, it still returns it's true, because we can take the return value of this if expression and assign it to our name. And then we can switch it to val, because we don't change it anymore. We just assign it once. So what we also can do is, if we use the try catch block, we have a try and we say, well, we use catch and we have our exception here. And as we can see, it still gets printed out, it's true. If we throw an exception here, by the way, as you can see, we do not have to use new to create an object. We can just create it like that. And we also do not have to use a semicolon at the end, because Kotlin doesn't forces you to use it. You can, but as you can see, it's grayed out. You do not have to use it. So as you can see, if you throw an exception, then it's false gets returned. So we do not have to assign it ourselves, but can just take the return type of our try expression. So let's get further. What is also an expression or a statement we use often in Java, it's the switch statement. As you can see, Kotlin doesn't know the switch statement. But what Kotlin knows instead is the so-called when expression. So let me create a variable, let's call it any, and assign it the type any. Any is like the equivalent to the Java object. So that way I assign it like that so that I can just switch the types easier. So now let's say when and add the any in there. Now in these curly braces, you can add pattern matching branches. You can, for example, say is string. And inside there, you can say, well, .any is a string. And as you can see, it gets printed out, hello is a string. But what's also cool is, because Kotlin knows inside this branch, well, any has to be a string, you can access all properties of any because as a string. So let's say it's a string of length, and then you can access the any.length. And as you can see, it prints out hello is a string of length 5. But we can do much more complex stuff. For example, we can say in. If it's in a range or in a list, we can say in 1 to 10. So if it's in a range, then we can say print line is $any is in 1 to 10, for example. And if we now switch that up to, for example, 3, as you can see, it prints out 3 is in 1 to 10. So that way you can do some advanced pattern matching. You can also, for example, do exact matching. You can say 3, for example, print line is 3. And as you can see, it now prints out is 3. So you can also check for equality. And that way you can do some really advanced pattern matching. Also, for example, check if something is in a list or something else, but I will keep it simple. So let's assign the result to it and say, let's remove this print line here. and use the implicit return of these expressions here. So as you can see, we get an error. Why? Because when expression must be exhaustive, add necessary else branch. Because it's possible if we, for example, add a different type, that's not covered in these branches. So what we do is we add an else branch and say something else, for example. And if we now just, for example, assign 11, and we then check for the result here, we can see that something else gets printed out. So that way you can do like the default case in the switch statement, but you can just assign the value immediately without having to assign it yourself or do some break, some switch case break where you have to stop in a case and so on. So in my opinion, that's really cool because Kotlin emphasizes you to use expressions wherever possible. So let's switch it up a bit and let's check how we can write some functions. So let's create a simple function. Let's say we have our hello function. Let's have our hello function right there. So we have our hello function and say we have our string right there. And we return the string. As you can see, we put the return type of a function at the end. But what's important is, if we remove this type and we do not return anything, Kotlin still returns unit. So for example, if I have my result here and I assign the value, the return type of the return of hello, we can see result is assignable, as the result is assignable of hello. So, and you can even access properties on your result because unit is not just void like in Java, but it's an own type which gets returned. So, but let's just change it again and let's say we have our string right there. So as you can see, if we just create a simple function, we say we have our hello and $name. And as you now can see, if we simply call it like that and add world to it, then as you can see, it prints hello world. So how can we make that code more concise? First, it's important to know you don't have to set var or val in front of it because the arguments in a function are always null, or not always null, are always immutable. So that way you cannot change it. You can't, if you want to reassign it, you cannot do that because Kotlin doesn't want you to change the arguments. So what you can also do is, because Kotlin knows so-called expression bodies, if a function immediately returns like that and it has only one line of code, you can do it like that. You can remove the return type here, and the return keyword, the braces like here, and just use an equal sign to assign that. And now you can write it on one line, and it does exactly the same as before, but you can write it much more concise code like that. So what you also can do is, because in that case, Kotlin can infer the return type because it has to be a string. You can even remove the explicit string type here. And as you can see, it still works. If I change it up to WeAreDevelopers, you can see the code still compiles as before. So let's just make some more complex function. So let's say we have a function called createBox. This takes a width as an integer and a height as an integer and returns a string. Let's create, don't use an expression body because it's better visible like that in that case, and say we have a box with width and height of height. And now let's call this function with 150 and 100, for example. And as you can see, a box with width 150 and height 100 gets printed out. So let's say we go back to this code later. We say, oh, okay, yeah, well, let us add some coordinates like that in an x coordinate and the y coordinate and add that like that with x and y. Now we go back to our code where we call that function. We say, oh, okay, let me add it. Okay, yeah, I've added at the front. But now I see, oh, I've added it at the wrong position because like in Java, you would just have to put it in the right order so that it gets assigned to the right value, of course. To avoid that, Kotlin offers something called named arguments. So what we can do instead is we can say, well, I want to assign 0 to x, and y is 0, and the width here is 150, and the height is 100. So that way, as you can see now, the code is correct again, and we do not have to use the same positioning as in our function declaration. So you can just, for example, I could put the height at the front and however I want to. And that way you can use it like a so-called builder pattern to just add the parameters you want in the order you want. So now, but to go even further, let's say you want to create an overloaded function. Let's say you want to create a box with default x and y arguments. So let's say you do not want to pass in x and y. In Java, you would do it like that. You would say, well, I have my width and my height, and I would call the create box with my width and my height and 0 and 0. And that, of course, would work, but for every possible combination, you would have to create an own function which is overloaded. Kotlin doesn't want you to do that, so you can just use the so-called default arguments. You can say, well, if x is 0, if x isn't set, use 0, and if y isn't set, use 0 as well. And now, as you can see, we can remove these two, and if it gets recompiled, we see that it's still 0 and 0. So because we set the default arguments, then we do not have to set it by ourselves to or create an overloaded function. So, but we can go even further and we can say, well, if the height isn't set, I just want to use the width, the value which is stored in width. You can do that by just assigning it like that. And now we can just remove the height. And as you can see, now it gets printed out a box with width 150 and also height 150. So that way we can just create one function and use it in many different ways by using default and named arguments. So, but let's make it even more concise by saying, well, I want to use an expression body like that, remove the string. And as you can see, we have written it on one line and haven't used that much code like you would do in Java. So from functions, let's jump over to some loops, to some list iterations. So if we would do it imperatively, how would you iterate over a list? Well, we would use a loop. We also can do that in Kotlin. Let's say we have our I and we want to say we want to loop from 0 to 10. Let's say we have an in and we use 0 to 10. And let's print out this like that. And as you can see, it prints out from 0, including to 10. When we iterate over an array, we often only want to iterate until the upper bound, so not including the upper bound. To use that, we can use the so-called until function, which, as you can see, it only iterates from 0 to 9 and doesn't iterate to 10. So just a quick glance at the later part of my presentation. What does this until function really do? As you can see, if we just hover this function, it's an infix function, a so-called extension function on the type int. So it extends the int type with the until function. But just to make it clear, it doesn't change bytecode or, for example, adds this function to the integer class. But what it really does under the hood is it creates in the Kotlin standard lib, creates a function, a static function, which takes 0 like that as the first argument and 10 as the second argument. So as you can see now, it's in the compile code, it's called like that. But for the developer, it's much more fluent to do it like that. But it doesn't do bytecode manipulation or anything like that. So let's go back. Let's say, well, 0 to 10. Let's say I want to step over some methods. So we can say, well, let's take a step of 2. So let's say we have like that. We have 0, 2, 4, 6, and 8 because we step over every second emitted value. So what do we do if we want to step, for example, from 10 to 0? Well, we cannot do this because 10 is always greater than 0. We cannot use this range, but we can use the so-called down to. it's like the until, but the other way around. So as you can see, it is from 10, 8, 6, 4, 2, and 0. It's printed out. So, but now let's use something we have much more often, for example, a list. In Kotlin, you create a list like that. You use the list of function, and you pass it the elements you'd like it to use. So hello world, we are developers, for example, like that. And now we can iterate over it by just using the in keyword. And as you can see, it emits hello world and we are developers. So what's also important is this list is immutable. So if you want to add something to this list, it's not possible, because by default, all sets, maps, lists, and so on are immutable in Kotlin. If you want to create a mutable list, you would have to use a mutable list of to be able to add an element like that. But let's switch it back to make it immutable again, because we don't need to add something now. So we can iterate over it like that. Let's switch it to an entry. But what if you want, for example, to have the index beside our entry? We can use the so-called with index. As you can see, we have many different operators available on our list, but let's just use the with index. And this, as you can see, outputs, instead of just the value, an indexed value, which also contains the index beside the value. So we could just access it like that, for example, with entry.value. But Kotlin supports so-called destructuring. So what you can do is you can just say, well, the first of these indexed value is stored in the I, and the second part, the value, stored in the variable value. And as you now can see, we can say I equals to $I and value equals to value. And as you can see, if we now print it out, we see that the index is always printed out right beside the value, but we do not have to access the parent object like the entry, but can just destructure it and use it like that. So now we have seen how we do it sequentially, but what we often also do in Java is checking for null. So for example, we have a list and maybe some elements in there can be null, so we will filter them. So how does Kotlin handle null safety? Well, let me just first show you how Java handles that. Of course, you already know that, but I will show you some things maybe not everyone has thought about. So let's say we have a function, let's call it string, and say hello name. And we put in a name as a parameter, and we say return, we say if the name is not null, then return hello and the name, otherwise return null. Well, prior to Java 8, this was the only way you could write it, but the caller of this function wasn't sure if it's nullable or not. So if he gets a value or null, if it's not commented. So what we can do since Java 8, we can add an optional here. And let's just import it quickly. And just say we want to wrap that using an optional. But as you might see, this code is valid. Even if Kotlin yells, even if IntelliJ yells at us for using null, you can assign null to optional. So if somebody calls this and thinks, oh, well, it's an optional, so I can just check if it's present or not, this object could be null. So you never have real null safety in Java. In Kotlin, on the other hand, what you can do is, let me first write two short classes to show it to you more easily. But let's start it with the simple same function like on top. Let's say we have our function hello name, and we put in our string, and we return the string. And let's write it exactly the same way. We say name not equals to null, then return hello name, and else we return null. Now, as you see, this doesn't compile. Why? Because null cannot be a value of a non-null type string. What does that mean? Kotlin doesn't allow you to return null from a function which defines that this is that it's not nullable, because if you do not explicitly tell Kotlin that a type is nullable, then Kotlin decides that it's always not nullable. So you cannot return null. The same thing like that, you cannot pass null to this hello name function, because the name here is not nullable. But how can you tell Kotlin that it's nullable? Well, you just add a question mark at the end of it like that. And as you can see now, the input is valid and the return type also is valid. So what does that question mark really do? First, again, Kotlin doesn't change the bytecode. What it really does is it creates comments in the bytecode for the Kotlin compiler to tell the Kotlin compiler, well, this function, this string in here might be null. It doesn't create an own class or an own type, for example, an optional string type. It just creates a comment, and the comments don't get parsed by the JVM or the Java compiler. So Kotlin just creates some comments, but it doesn't change your bytecode or does some fancy stuff. But what you can do that way is you can make sure that everybody who calls this function knows that this is nullable. So, but let's make that a bit more complex. Let me just create two classes. Let me just create the first class person. By the way, I will come back to classes later just to show you how a class gets created. You do it like that. You define class, then the name, and then you add your default constructor. You say, for example, well, name is a string, and you add an address. And this is an address, and we say we add another address, and address has a string, and zip, which is also a string. So now let's create a function. Let's create a function getStreet, which takes a person as an argument and returns a string. Let's return the string. It's in Java. What you would do is you would say person not equal to null and person.address not equal to null. Then return person.address.street, else return null. Now, as already mentioned before, you cannot return null because this is not optional. So let's say we add that it's nullable. But also let's say, well, person, Kotlin already yells at us because, well, person cannot be null. You do not have to check for null, and address also cannot be null. So you don't have to check for null either. But let's in this class say, well, address can be null, and the input here might also be null. So as you can see now, Kotlin doesn't yell at us that much anymore, but it still isn't happy how we code. But let's change that up later. Just to give you a quick roundup about classes, you can see with val, Kotlin creates you the backing getter which you access if you access the person.name. It doesn't create a setter because it's a immutable property. So let's say we want to make this more concise. We can use, instead of this null checks, we can use so-called safeguards. So we can say, because Kotlin knows person might be null, we can use a question mark and then access address, and a question mark again, because address can be null too, and add access street. So we can just remove all this code here, and as we've seen before, just convert to an expression body, remove this optional explicit type because Kotlin knows what it is, and we have written the exact same code but in just one line of code, and it's, in my opinion, as readable as before, even more readable in my opinion. So let's say we have our street right there and we want it to be a string. We use the getStreet with null. As you can see, you cannot assign this getStreet to the string to this street variable because it's not optional. So if you want to check, well, if this is not null, take it, or otherwise use something else, use something different, then we can use a so-called Elvis operator by using question mark colon and say, for example, no street. And if we call it like that, if we call the street like that, you can see that no street gets printed out because our person in here is null. So let's say we want to change it and say we have our person from, for example, Christian, and say null. By the way, you could also do the following. You could also assign null to it like that. So that way you do not have to specify the null address like that. As you can see, it still prints out no street because address is null. But if we add an address and add a street, then you can see that it prints out street. So that way you can really code really in a nice way, null safe, without having to bother about checking null everywhere, because if a function doesn't return a nullable type, and it can't be null. So that's the part about functions I'd like to show you. Now I would like to go more in a functional direction. So how would you create a function in a lambda function in Java? Well, you would do something like that. You would say, okay, I create a function. Now I have to think about, what is it? Is it a predicate? Is it a supplier? Is it a consumer? Is it a function or a by function? And when you know that, then you say, okay, I want to create a function which takes a string and returns a string, and let's call it hello function. This takes then a string and returns hello string. And when you want to call it, you would call it like that. You would call it hello function, apply, and then you would apply your string. You can't call it like, for example, like that. You would think of from a lambda, because that's just an interface with one function in it. So how did Kotlin solve that? Let's create a function which checks for a string if it's of length 5. So we create a variable called isStringLength5, for example, and then we say, well, what's the type? The type is, it's a lambda which takes a string and returns a Boolean. And it's important to say you can just add as many parameters as you want to. Kotlin will, behind the curtain, will create the correct lambda for you, the correct type, because in Java, you can't create, for example, a try function. You would have to create your own functional interface. But let's keep it easy. And let's say we have one input and one output. Now how can we create the lambda? We use curly braces to tell the Kotlin compiler what follows now is a lambda. And we take the string and we return string.length equals 5. So what can we do is, if a lambda only takes one input parameter, then we can remove this explicit string and we can use it. So it refers to the implicit one input lambda. So we can write it much more concise. We could even change it. We could just remove that, but then we would have to use it. We have to define our type explicitly, because Kotlin cannot infer the input type, of course. But let's just remove that and switch it back to that. And how can you call it? Well, you call it like you would a normal function like that, hello, for example. And as you can see, it returns true if it has 5 characters, or it returns false if it has 4 characters, as you can see. So now you can use this lambda to just call it, but let's use it inside a filter. Let's say we have our list at the top from prior. So let's use it and let's just call filter on it. And as you already can see, you do not have to use stream to create a stream, because Kotlin has decided that by default, you mostly want to evaluate the result of the stream immediately. I myself have not really that often used a stream to pass it around inside a function. I've most often created the stream, filtered something or mapped something, and then collected it right away. So in that case, we by default, Kotlin evaluates it right away, but of course you can just access the stream like you would do in Java. But let's just do that like that. Let's say we have filter and create a normal filter. But as you can see, Kotlin offers many different filter functions from their Kotlin standard lib. So for example, filter not null, filter index, and so on. You can do the same also by grouping by, where in Java you would have to create a stream and then collect it by using some kind of collectors from some kind of grouping by collector. Here it's built into the language. So let's create a filter, and let's say we have our lambda function here and call it like that and say is string length 5 and then pass in the element. Now, one cool thing is if the last parameter of a function is a lambda, then you can put the lambda outside of the parameter body right here. And now we can even remove that because it has no parameters anymore. But now, as already mentioned before, if lambda only has one input, we can remove that element and use it and call it like that. And as you can see, it still outputs hello world. But because we already have a lambda here, we can just call it like that. We can remove all that and we can say, well, call this lambda. And as you can see now, it still puts out hello world. And we have written really concise code. So for the next thing I'd like to show you is, I've shown you before this until method on the int type. So wouldn't it be cool if we could just if we wouldn't have to pass this string inside our lambda, but if we could just do something like that, for example, say hello, and then is string length 5, and then check it like that right on our string object. Well, of course we can do that, because what's important to know is Kotlin by default makes every class final. So let's say I have a class here with better person, for example, which extends person. As we can see, we get an error. The top one you can ignore for now. At the bottom here is this type is final, so it cannot be inherited from. So you can of course change that. You can say, well, I want to have an open class, and now we get just the other error where we have to use the constructor. But here we can now use it. But Kotlin wants us to extend classes in another way. How can we do that? Well, let's say we want to extend the string type. How can we do that? Well, first let's switch that back to be a simple function. Let's say we have our function here, and this takes a string, and let's use this equal right there and say remove these curly braces and say we have our string. Now, instead of passing the string as a parameter, we can say we want to call this method on a type, on our string type. And now we can remove this parameter right here, and instead of this parameter we use this, because this now references to the type we call our string length method on. So let's just uncomment it. As you can see, this works again. So you can just call this string length 5 function on our string type. Now, don't make the mistake to think, as I said, that this adds the function to the string class. What it really does is, again, it creates a static method, which is called string length 5, and which takes the string and puts it in the Kotlin standard lib. So it also gets called like that. It gets called in the compiled code. It looks like that. It gets called like that with the hello in there. So you do not change your existing class. And so that way you can also change, for example, your person. You can extend it like that. You can, for example, say you have your person and you extend it, but you can also extend Java classes. Let's say, as I already mentioned, we have this Java class on top there. Let's say we want to extend it. Now, what we can just do is, let me remove that. We can say, well, we have a function, we have our Java class, which is defined in the same project I'm in now. And let's say we want to create hello, we are developers. And now we can say hello world. And now we can create an instance of our Java class I've defined here on top. And now we can just access the hello, we are developers right there. And as you can see, we can also access the hello name optional from the function which we have defined in our Java class. So that way we can extend everything, every class or every type we want without having to actually extend it, which in my opinion is extremely powerful because you can extend anything you want. So for the final part, let's go back to the classes. I've already shown you a bit about classes. Now let's just create a person. Let's just create a Christian right there, and let's create a person too, which is also called Christian. Now let's compare them. By the way, if you use double equal in Kotlin, then it does the dot equals check. If you use triple equal, it uses reference check. So double equal, of course, returns false. Why? Because the equals doesn't check for the properties here to be the same. But maybe you have already used Lombok, and with Lombok you have the data annotation. In Kotlin, you can use a so-called data class. And as you can see, data class now takes care of the equals and the hash code, and now it returns true. By the way, what's also cool is, for example, if we use, if you have to use with big decimal or something like that, say we have a big decimal, we create one, let's say 1, and we have a big decimal 2, we have a big decimal 2. Then, and we want to add them together. In Java, you would do something like plus, and then your second big decimal, but that's not really that fluent. So what can you do instead? You can just say replace with plus. And as you can see, this works. Why? Because Kotlin allows so-called operator functions. So you can override, for example, the plus and the minus for your own types. So for example, if you want to concatenate things, then you can just add one operator functions by yourself, and can, for example, as you see under the hood, it calls the big decimal add function. So that way you can write really concise and fluent code without having to do the ceremony of using for example dot minus and then put your big decimal in there and so on. So I think this is also really cool to make it fluent and to write as less code as possible. So what you also could do is, if you, for example, want to add static methods, you can do that by using a companion object and say, for example, function I'm static here, which is a function, and then you can just call person.I'm static on it. And like that, you can do it like you would do it in Java. And you can also create, of course, your own properties which aren't defined inside of your default constructor. But you can, for example, do something like that. You can say you have your variable other var, for example, which is of type string. And then you can say, well, the getter for it is, let's just say println get called and return field. Field is the specing field right here at the top. And you can say to set it, you can say value and say, for example, just to that you see that it's called set value, and you say field equals to value. And now, as you can see, we can here access it like that. We can say we have our person type Christian. And then we can access other var. And as you can see, get was called, but there is nothing set in red, but we can say other var is set, for example. And now if we access other var, then we can see that get called is set. As a get called gets called again, and is set is now the value in there. So without having to use getter and setter, you always just access these getters and setters which get created. So you do not have to make them private or something like that. You always access a getter or a setter either way. Yeah, that's it from my coding part. So let's go back into my presentation. Yeah, that's my last slide. Yeah, it's over. It's done. Thank you for listening to me. And if you have any questions or like to get in contact, just write me a message or add me as a contact in LinkedIn, and I will be glad to now answer some questions which there might be. Yeah, that's it from my live coding. Thank you.
Hey, Christian. Welcome back to the studio. Nice talk.
Thank you.
Lord of the Rings memes always work. And nice shelf, I have to say. So, and
Thank you,
not
thank
only me thinks that your talk was awesome, we also got some questions from the audience. So when you are ready, first one.
Yeah, for sure.
Does Kotlin support string interpolation and runtime?
I'm not really sure what so at runtime. So I'm not really sure what if I understand the question correctly. So you can of course do something like for example, if you have let me remove all that. If you have, for example, a function and you have your name in there, so you can of course do something like and like that. You can of course do that, but you of course have to tell Kotlin that it's like that. You cannot of course do name plus name, so that of course you can do, but I'm not really sure if that answers the question, I think, but maybe I've misunderstood the question.
If something isn't clear, please feel free to just submit another question. So
Yeah, thank you.
let's go to the second one. Kotlin is syntactically really similar to Scala. Is that accidental or is that intentional?
No, it's cool that somebody mentioned that, because Kotlin has taken the cool parts from many languages and put them together. So they have, for example, JetBrains has also analyzed many of the projects which are written in different languages, and has, for example, seen that, well, functions by default here are public, because the functions are mostly in the project, the functions are public, so you can access them from outside. So it's really, Kotlin has taken what they think the best parts from all languages and put them inside Kotlin. But that's not coincidental. Scala was a heavy influence to Kotlin. Absolutely right.
All right, then the next one. Are there any resources you can recommend for learning Kotlin, especially for lambdas and coroutines?
Yes, absolutely. So just for other people which don't know coroutines, coroutines are like to do like parallel coding, like doing things in concurrency, not parallel, sorry, in concurrency. So in my opinion, one awesome book I've read is the book from Venkat Subramaniam, which is, I think I might find it, Venkat Kotlin book. It's a really cool book, Programming Kotlin, exactly like that. It's really cheap and it's really cool, and you see many different we see all kinds of topics handled in there in a really real world, with real world examples. So I can really emphasize you to use that, or just what I've done when I started is just check YouTube for nice coroutine, for nice tutorials. There are some really nice people on there. I've also created a talk for how to create a coroutine, how to create Spring Boot applications, first with REST template and then with coroutines. Maybe if I'm allowed to speak again, maybe we can add that in too. But this book is awesome, and also I think the official Kotlin website is also great for learning coroutines. It's really great.
Perfect, thank you. Yeah, and now we already have a topic for your next talk. Perfect.
Exactly.
So, another question. Knowing Java, is knowing Java an advantage or a problem to approach Kotlin?
I think it's neither, because what I've seen is if you start writing, if you haven't coded in Java, it's not a disadvantage at all, because you come in with a fresh mindset. But because if you know Java, then you know some of the constructs which Kotlin also takes. For example, you know for example, with Decimal and all these APIs, you know them from Java, so you can just apply them to Kotlin. And if you use, for example, IntelliJ or something like that, or another IDE, then it often will help you to convert your Java code to Kotlin code. So what also IntelliJ offers is you can take a Java class and put it in a Kotlin file, and it will then try to convert it. So it's whether an advantage nor a disadvantage, but I think I think Kotlin, the learning curve is really nice to start either if you have Java prior Java knowledge or not. But I have to say Kotlin is, in my opinion, also a cool language because you can write on so many platforms, like for JavaScript or even for native code. So I think Kotlin in the future can work. We will see Kotlin in many more places than now. Yeah.
So no matter what your experience are, start with Kotlin.
Yes, exactly.
Yeah.
I would really, I think, for example, many companies I know, they are also searching for Kotlin developers, but they often just say, well, Java or Kotlin knowledge, but they would appreciate if someone would have Kotlin knowledge. But because if you know Java, then of course you have an advantage if over someone who hasn't coded in a object-oriented or functional language before. That's for sure.
Mm-hmm.
Yeah.
All right, thank you. Another question. Aren't features like operator functions considered dangerous, for they could inject unintended behaviors on large amounts of existing
Exactly,
code?
Yeah. Sorry, no, exactly. I just had to smile because that's exactly the same thing that I thought about it, and I still think it's dangerous. But especially because you could override, for example, plus with minus and something like that. And we've already seen, for example, I think in some C languages you also can do that. But in my opinion, it's important for the programmer to be aware of that. So if somebody does that, then, for example, if you see that in a pull request, then you have to say, please don't do that. For example, I would never. There is, in my opinion, no valid point in overriding an integer plus or minus. But for example, if you have a big decimal, then it's great to do that, to be able to write much more concise code. But you have to respect the language. But it's absolutely correct that it can be dangerous. Yeah.
Right, thanks for that insight as well. Next question. Extending the classes outside looks fun, but it's actually a two-part question. First, how can you find out how the class was intended, what functions you have available?
That's a good question. Well, if you call it, you will not really have you can't see if it's an extension function or not, but it's important to know that you cannot override an existing function. So let me switch back. If you, for example, have a function in our class which is called hello, you cannot create an extension function which is called hello, which then overrides it. So you can just enhance it. Also, what's important is you cannot add properties to the class itself. So for example, maybe I can revert it and show that again. For example, if you have this person right here, and you cannot add a property in there or edit the existing functions. So you can only add to it, but you're absolutely right. You cannot see, in my opinion, but I have to be honest. I haven't really checked if you can do that, but let me check that. Sure. Let's say if we have a function person test, for example, which returns just that, and we say we create a person and not a period. We want to create a person, and let's say we have person dot, and we can say test. Well, here we can't really see if it's from the class itself or not. I don't know if Kotlin really wants you to be able to see what was in there by default or not, but I think you can't really see that. But I'm not really sure if that may be possible. Yeah.
All right, Christian, thank you so much for the awesome talk and the insights in the Q&A, and looking forward to your next talk, as we discussed.
Thank you for having me.
Bye.
It was really nice.
Awesome.
Bye.
Bye, till next time. All right, and we will go into a short 30-second break before we start with the third speaker. Stay tuned.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone. So, right to the next speaker. His name is Dominic. He's software developer at Took, and as he takes care of clean code through frequent code testings and reviews, he's a real expert when it comes to testing. Welcome, Dominic.
Hello. Hi.
Hello, Dominic. Good to have you.
Thank you very much. It's pleasant to be here.
Awesome. So, would you mind telling the audience and me a bit about what we are going to learn from you today?
Yeah. Recently, through some last years, I found out that we are very often trying to create programs in languages like Java, and where the OOP is deep in the basics of this language, but we are very often doing it wrong. And I want to point why we are doing that wrong and how we should write it in a correct way and going towards this OOP, not writing some Java beans, more structures, and so on.
Okay, Dominic, you got my curiosity, and I think this of the audience as well. So, without further ado, stage is yours.
Thank you. Okay. So, hey everyone, I'm Dominic. I work at Took. I am also the committer of Apache Areas, and today I'd like to talk with you about object-oriented programming, and especially want to focus on the principles of that paradigm because I think we forget about them very often. But at the beginning, let's start with the quick definition. What is object-oriented programming? If you look at for example, Java tutorial on the Oracle website, you can find out that there is some analogy in surrounding world. We have real-world object that you can see wherever you are. It could be your dog, desk, book, or whatever it could be. And those objects share two characteristics. They have some kind of state and also the behaviors which can be assigned to that objects. And based on that simple idea, we can craft also our objects in our software. So it means that our object that we are creating, of course, in terms of classes. We are grouping them in classes, and they store some state in the fields and exposes the behavior through their methods. So it means that our programs we should more model as a set of simple objects. And here I encourage you to think about them as small computers talking with, and of course, those small computers have to talk with each other, and they are doing so by calling the method of another object. And it's also nice to think about those communication as passing a message between the objects that we have. If we have this analogy, it will be helpful for us to make them more separated. Okay, isn't that simple? Probably it is. That's why in the object-oriented programming, we have some principles. And those principles are really important because they tell us how to design and organize classes in our code base. And it doesn't only work on the level of designing classes. The rules that I will mention in a moment will also work in several situations when you are designing modules, microservices, or even the communication between the whole systems in your environment. And we have four basic principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Those principles will be the guides for our presentation today, but additionally, we also have some additional set of principles. We have solid principles, and the acronym SOLID is created from the first letter of the principles in that set. We also have GRASP, but this is more the umbrella name, which group a lot of different rules that we should obey. Additionally, we also have some other principles, other guides that are not grouped in any set, but I will also talk about them during the presentation. So let's dive into the first principle of object-oriented programming, which is encapsulation. If you read the tutorial, for example, about the encapsulation, you start your object-oriented programming journey, you can find out that encapsulation is mostly about information hiding. And the second thing that is connected with encapsulation is grouping the data together. But for me, the crucial is to derive from the method, from the paradigm name, how we should think about this principle. And this is about building a capsule in our software. If we think in such terms, we can find out that we are able to reduce the complexity of our system, of our classes, because we have these capsules, and something could be complex inside, but outside could be pretty simple. It's also something that could bring us quite big security, because we are protecting everything which is inside this capsule from everything that is outside, and also in opposite way, we are protecting outside world from everything that is inside. And so let's design our first class. We'll be doing that presentation in the domain of task management. So we created our first class called task, and here we put one property name. And probably now you know that this class designed in such way doesn't encapsulate the state very well. So you are adding the private keyword in front of the field name. And very often in the tutorials, I found out that people say, okay, and now this is the moment when you should add some setter and getter, because someone needs to access this field and do something with your object. And even with the modern libraries that you have in Java, like Lombok, you can generate such getter and setter for one field, or maybe for all the fields that you have in the classes. And I'm sorry, but this is not the good approach, because for me, this is the same as putting the public keyword in front of this field, and it doesn't encapsulate anything in our object. I think this is the technical debt that we are still paying for having Java beans in our software. And even if we don't know why we have Java beans and for what problems was solved by Java beans, we are continue to use this approach. In such way, we are more thinking in terms of the structures in our software. And I don't want to say that structures are bad. Structures are pretty useful, for example, as data transfer objects. But when you are creating the real objects, then you are not creating the structure. And this is our problem that, for example, in Java, we have the classes and we don't have a separated word for structs. And we should probably avoid that. And how to avoid that? Let's look at for example, at the setters. What's wrong with the setters in our objects? Let's imagine that you have a method set xyz, and you have to ask yourself a question: does this name correspond with the name that you are normally using in your domain? And when I will be referring to domain, I'm not talking about domain-driven design. It's of course a little bit connected, but I am talking about the focus, about the niche in which we are creating our object, creating our software. And for example, if you have, I don't know, book, and you want to, you don't send the message set page something, you are more turning the pages than just setting the internal property of this object. And that's why instead of setters, it's nice to use a proper operation name. Maybe it's changing one variable, one field inside. Maybe it will change several fields inside, or will, I don't know, call another method. We shouldn't care, This is the proper operation name should be enough for our object. And this is something that we should see outside, not the field, how it's named internally. Okay, the next thing, what's wrong with the getters? If you have simple getter which returns the immutable value, as here we have some wrapper on string and we want to know what is the name of our task, no matter if it's a getter or maybe this is other kind of accessor, if it returns some immutable value, no big deal. But if you return something bigger, for example, from our task, we want to get the list of attachments, and we can do something like that, or we can generate that via Lombok or something like some library like that. And then we have a problem because this list could be changed by someone, could someone could add something to that, remove element, resort this element, and so on. So when we are returning something which we use internally in our object, we should always wrap them in some immutable collection. And even if we protected the list per se, we also have to protect the things that are in that list, because they could also be mutable. So maybe we should return some copies of the elements that we have on that list. And we very, very often forget about such changes, and then someone outside of our object could change our internal state. Next problem, we can return the value that is available or not. For example, someone could be assigned to a task or not. And instead of having getter like that, I would prefer to have in the type information that this value is optional. And here I wrap the field assignee ID in that getter into optional. But you can ask yourself a question. Maybe the optional field will be helpful for you. There will be, of course, a lot of mess that you shouldn't use optional as field type in your projects, because what? If you read what are the reasons why people say that optional isn't designed for being the field type, you can find out that they are very often refers to Java beans. And as I mentioned, we don't want to create Java beans. Yeah. And for example, here, when it's helpful for your project, when it's helpful for internal state of your object, it's fine to keep it as optional, especially when you encapsulate, and no one should care outside how your object works internally. But the main question connected with getter is also, do you really need to expose this getter outside? Is there anyone who really needs to know about that information? And do you want to publish it separately? Maybe you should always group some parts of your state that you have internally and create some view which describe correctly what is the current state of your object. Okay, knowing about that, maybe let's redesign our class that we started with from scratch. So instead of focusing on the fields, we should be more focused about the operation that we are exposing for our class. So our task class returns the name of that task. It's fine, it's immutable. We want someone to get this information. And we have another methods which are more specific for our task management system. So we have the methods like assign to, resolve, reopen, and so on and so forth. And you can ask me why I'm not using the public keyword, for example, in this class. And I think of course, I can say that it doesn't fit on the screen, yeah, because it's too, it could be too wide. But the case is that visibility is also really, really important. And you should start thinking about your object that at the beginning, everything should be private. If you need to expose something outside of your class, make it package private. If you want to support additional inheritance, maybe make it protected. And the last modifier to be used is the public, because then everyone around, at least in Java, could access your method, your class, and it's not well for your design when you, for example, want to create more separated components. And personally, I think there are annotation like visible for testing. It's not very good annotation because it means that somewhere in the design, maybe we make some error, some mistake. Okay, and also, if you think about encapsulation, for me, encapsulation is really tight coupled to the abstraction, and this is the second paradigm of object-oriented programming. The whole idea behind abstraction is that implementation, some details of our system, it's something that changes very, very often. But some higher structures, some model of our system, some abstraction created on top of the thing that we are modeling is something that stays with us for much longer time. So it means that if you think about that and you want to create such abstraction, you should hide or even remove all the unnecessary details from the things that you are modeling. It means that you should expose outside, especially outside, only the essential information that are crucial for another object which could be interested in your things. If you do so, you are hiding the complexity of all the things, the same as you have in the encapsulation. Second thing, it's improving the readability of your object because you only have a constant specific API, what you can do, and you don't have to deal with all the details that you have somewhere hidden inside that API. And thanks to that, you are also able to be focused on a specific problem that you are trying to solve with the class, component, or module that you are trying to use. Okay, so we are creating such abstraction, and how we should create such abstraction. The first thing I want to talk about is the information expert principle from Grasp. This principle is about delegating responsibility. And we should delegate it to the object who has most or all the knowledge necessary to perform some task. So, for example, let's imagine that we have some kind of service, and here we deal with the Java bean. It's called task still, yeah? We get the status, we get the assignee ID, and we have some condition that, for example, when the status is closed, the assignee ID is not null, then we perform some action. But when you look at this code, you see that all the things, all the necessary things for the condition, maybe also for the execution in the if statement, are inside the task class. So why don't talk with our task object and pass the it will be its we can delegate it to this class, and it will be responsible for returning the proper values, and it will keep it privately. So, for example, we can a little bit fix that code using in the if statement condition in the condition task. Can it be reopened? And if so, we can, for example, call the reopen method with some specific reason. The code looks a little bit better, but it could be even better because there is a rule called tell don't ask, and it means that our object should be responsible for handling the problems. We want to reopen the task. We shouldn't be so focused on our task class that we first have to ask politely, can it be reopened? No, I want the task to be reopened. And if the task cannot be reopened, let's tell me that with, I don't know, exception, value false, or something else that it cannot be done, or maybe return the new version of our object. Maybe no news is good news, so return void. Maybe the value true of the operation was successful, but it will be the duty of that method to tell me if the operation was successful. But to do so, to write code in such way, we should think about our object. They should keep their state always in a valid form. So it means that we should perform as quick validation as it's possible. Personally, I think this is the anti-pattern where somewhere you, for example, created some object, you perform on it some operation. In some moment of time, you are asking it, are you still okay? No, when it's something is wrong, I want to, for example, I don't know, in constructor or in any method, receive instantly the information that parameters you gave me or the change you want to apply is something that cannot happen in our code. And in such way, we are creating our information experts. But when we are creating so many information experts, we have to respect each other. And this is described in the principle called law of the matter. This law is mostly about not talking to the strangers. Let's imagine that we have our task class and it has the logged work class somewhere internally. And how we can interact with that object to log some work? We can get work items, okay, but what are work items? We don't know. It has an add method. Okay, so maybe this is a list, maybe it's something different. And here we have to create something new. For example, the work item. Doesn't look very well, yeah, because we don't respect that log work is also the information expert, and we are trying to touch the things that shouldn't be available for us. So the code would look much better if we just call the log work method on our logged work, and internally, this method will be responsible for delegating the, creating the work items and putting them on some internal list. Okay, so we respect each other. And here I want to mention also one of the rules of Grasp, which is creator, because we very often think about the creators that there are some kinds of factories. The object, which is only responsibility, is to create objects of another classes. And in lots of situations, it's fine. But we should also think about some local factories, the object that we created internally and just for using inside of our classes, and how that's how we internally, for example, created the work item And it's only here. It could be even the private class internally, and no one should care because we are responsible for creating this type and also maintaining it inside our code, and it never escape outside of our class. Okay, but sometimes we are not able to create easily some information experts because, for example, we think in terms of objects. So maybe sometimes we have the information, there is some algorithm or there is some function that has to be performed on our objects. And here we have the rule, the pattern called pure fabrication. In pure fabrication, we are creating some name, which is, for example, derived from the operation that we are performing. And we are creating some pure fabricated name for our object, just to have our object having only this responsibility that is really interested with. So for example, here, we don't want to put the calculate method, which calculate the final estimation for the task, for several tasks in each of the tasks, or maybe in amplification class or whatever else. We don't want to create the util and, for example, name it util. Yeah, util is the one of the worst name for the classes. Yeah, but we want to create such fabricated name like task estimation calculator and keep all the features connected with that in that our class. Probably if you will talk with your customer, you won't talk about the calculator. You will be more talking about the calculate. But for you, for the object-oriented programming approach, you need such class somewhere in your system. Okay, and when we have such information expert, we need respect that we have several such information experts and we just split them correctly. We are going according to the single responsibility principle. This principle is about creating classes or methods in such way that they have only one reason to change. And this is not about doing one thing. Okay, if we are on the level of method, maybe it's about doing one thing. But if it is about one class, it is more about managing one thing, about being responsible for one thing and doing it well. To do so, we have another principles which is helpful to design our software in such way. One of them is high cohesion. That's how we want to create our object internally. The cohesion is a way of measuring how much elements inside the module belong together, how much they have to be used in common, how much we have to, I don't know, read them, write them together, and so on. And probably you've seen in your favorite IDE that you have some hints that something is wrong with that tool, or maybe in some static analyzer tools you can find out that there is some problems. But I want to talk a little bit about the metric which stands behind that hints, and this is lack of cohesion of methods. The LCOM4, because this is the abbreviation and this is the fourth version of this metric, this metric tells us how many clusters of methods and fields we have in our object. And if the LCOM4 is equal to 0, we don't have any methods. And it's fine, because, for example, we are creating the structure and we know for what we are doing it here. We can have the LCOM4 on, with the value 1. This is the perfect situation. All the fields and all the methods are in some way combined together. And the LCOM4 is bigger than 1. This is the sign that maybe your class should be split into several other classes, but this is your design decision. You should decide, do you really need to split them? Or maybe not, yeah? Maybe you know what will be the further evolution of your object. Maybe you are creating a kind of facade. This is your design. You're still designing. Okay, so that's how you create your object internally. But outside, in communication, you want to achieve something opposite. You want your object to be low coupled to each other. And coupling is a way of measuring how strong one element is in relation with another one. So maybe it uses another object, maybe it knows about another object, maybe it relies on something, for example, on specific order of execution of methods, maybe it has to first ask, can task be reopened and then reopen that, and so on and so forth. And we want to keep such coupling as small as possible. If we do so, we are minimizing dependencies between the classes or even the whole modules. The changes that we are applying to our object, to our design, is more local, more focused on the one thing. And thanks to that, the components that we are creating are easier to reuse because we, for example, don't get the banana with the gorilla, with the jungle, and all the other things in our object, because they are so tightly coupled that you cannot use them separately. And here we also have nice technique for dealing with those problems and designing our object correctly. And this technique is called CRC cards. It's quite old techniques where on a small piece of paper you write some class of objects, name it just, and you write down all the responsibilities and all the collaborators, not the fields of that class, but the other objects which are necessary to performing fulfilling your responsibilities. And if the one of the second list is growing too big, you can split them in some way inside your software, and even without writing a line of code, you can use that technique and trying to solve the problems internally during the design session. Okay, so we also here, when we are splitting these classes, when we think about dividing the responsibilities, there are also nice, helpful techniques to do so. And this is called dependency inversion. Dependency inversion principle is about creating high-level components which are independent from low-level components in our software. And it means that in our code, if we do so, we are depending more on abstraction that we are creating, not on concrete objects. So let's imagine that we have some kind of task service. It will be in the middle of our application. At the first sight, we don't know how it's going to work. Maybe internally it will have all the operations. Maybe it will be a kind of controller in our system. It means when I think about the controller, it will be a kind of dispatcher, which will traffic route the traffic to another services, which will be more focused about specific use cases, for example. And what is worth mentioning, controller in Grasp is not the same as controller in MVC, because in Grasp, in terms of Grasp, we are more focused on the operation inside of the traffic inside of our, I don't know, domain or code. When we are on the level of code, of making decision, controller in MVC is more working on the HTTP level. Okay, so from our perspective, such task service will be a kind of low-level components. And we want to create such abstraction to create such high-level components. And we can achieve that using the indirection in our software. It means that what could be the sign of indirection? First, we have interfaces. We can also have some specific classes, especially abstract classes, which allows us to show that here we have some higher level component. And when we have such higher level components, the indirection could be also built using another design patterns, especially adapter, bridge, facade, mediator, and so on and so forth. So let's add this level of indirection in our software. So for our task service, we create the interface called task other. It will be responsible at the beginning only for one use case, adding of the task, and it will be a higher level component. Okay, so what we have to do to add a task to our system? We have to interact with, we have to interact with some RabbitMQ, for example, queue, send some message there, or we want to, of course, store the task somewhere in our repository. So we have some specific classes, but if you look at them, if you even look at the names of those classes, they are tightly coupled with the infrastructure things that we have under the hood. So for them, we also want to create some level of indirection. So we are creating event sender interface and task repository interface. And in such way, we are decoupled. We decoupled our low-level task service from all the other services which are more closer to the infrastructure layer. And of course, in some way, people needs to add something to our system, add new task. So we have a task controller, but this is not the only way how we can add tasks to our system, because, for example, we also can have the Kafka event handler because we receive the Kafka events with a new task created. Of course, that could be a lot of another ways how you can create the task in your system. But if you design your system in such way, you are able to create a kind of boundary. And here you can spot that in the middle, you have your domain, the domain of your problem that you are solving, and all the other things around are more focused about the infrastructure thing. And this is the example of hexagonal architecture, which is pretty useful for especially business application with very rich rich domain and rich intelligent traffic. So the hexagonal architecture is about putting in the middle of your application the domain model, also with application services working on such domain model, create a boundary of ports, in Java mostly done by interfaces, and also we have the adapters, which connects us with external world, with some databases, with some queues, with I don't know, with everything, yeah, with the mail system and so on and so forth. But thanks to this architecture, we are able to be focused on our domain code. Okay, but when we create such higher level components, we have to be aware not to create the leaky abstraction in our software. As an example, let's imagine that at the end of the string in Java, we create some specific list. We want to achieve some specific list. So we call toList method from collectors. And we receive the list. We try to add something to that list because it's available, and it's fine. But starting from Java 9, you have toList method. And if you call that method and on that list you try to add something, you will end with the exception. And what's the problem? The problem is that in Java 17, 18, and even with the 19th version released yesterday, we have more than 20 methods inside such interface. And some of those methods are pretty useful for every kind of list. Contains, size, stream. Yeah, you can use them no matter if the list is mutable or immutable. But you have also methods add, remove, set, clear. And if you look at this method, even on those methods' names, they imply that your object is mutable. And this is the problem, that if you create interfaces like that, you are breaking the interface segregation principle. And in that principle, the principle says that we should create small and concrete interfaces which are focused on specific abstraction that we are creating, instead of having one big interface with a lot of operations, because there will be always someone who will break our contract in some nasty way. Okay. With the abstraction, there is connected very tightly the third principle of object-oriented programming, which is inheritance. Inheritance, obviously, is creating another class by using the existing class as a base. So, for example, we can have our task class. We can always create object of the task class, but for some specific purposes, we need to create something more specific, like programming task and research task. Of course, the task class could be created not as extended classes, so we can prohibit that and, for example, create abstract class task, and then no one will be able to create the object only of the task class. He or she should always use some more specific class. No matter what approach we choose in our software, we should follow this substitution principle. This principle could be described in 2 simple sentences. Don't surprise me and respect the contract, because the whole idea is that we should create our specific classes in such way that can be always used in a place where the base class can be used. So what could be the problem from that rule? Let's imagine that we have our task class and it has the estimate method, which returns the estimation. And yeah, pretty useful if you want to take advantage of this method in the calculator. The implementation could look like that. Nothing fancy. But there is a problem with such definition of the method, because, for example, someone created the external task and he's not able to decide how to tell that, for me, estimation is not possible to be calculated. It could return null, it would cause a problem. It could return throw some exception. It also causes a problem in the calculator that we have created. And this is the sign where we don't follow also the open-close principle. This principle is about creating class methods or module that should be always open for extension, or when we design them in such way that they are open for extension, but in such way that they are closed for modification. So what does it mean? It means that we are creating, especially some base class, some abstraction. We should always identify possible changes and instabilities inside such abstraction that we are creating, and around them we should create the stable interfaces. And if we do so, we are creating protected variations. We can see what are the extension points, what could be different, and then the design of our base class could look, for example, like that we have the return type of the estimate method is the optional estimation. And this is the way how you should tell me the estimation cannot be calculated, or you don't just have the estimation in your code. And also, when you are creating such the inheritance structure, this is the point where we can create leaky abstraction if we don't obey the previous rules I mentioned. So, for example, if you want to deal with such base class which is not well designed, you, for example, in such calculator, you will have to, for example, check what is the specific type of the object that you received here. And for example, for external task, call it in try catch block and catch the specific exception. And all the other cases, you can just call the estimate method without any problems. I think there is also a problem connected with the seed classes that are pretty new feature in Java, and people are overusing it a lot. Seed classes are classes where at the moment of compilation, compiler already know all the classes that are derived from the base class. So here we have a status class which have two options. It can be success and failure. And in modern version of Java, you can even write the switch statement, which take advantage of this knowledge and know that there are only two cases, and we don't have to, for example, add the otherwise option in the switch statement. And the problem is that if this switch is somewhere hidden inside the status class, it's fine. No one needs to know about the success and failure classes. But when such switch statements are, for example, in several places amongst our system, adding a new class here will break our design and break all the clients that are using our status class. I found out that people describe such situation where you are designing a lot of sealed classes, that this is more the approach that we can call data-oriented programming, where you are focusing on achieving immutability, creating a lot of records. These records are used also in sealed classes, and if you have records and sealed classes, you can take advantage of pattern matching. And this approach is fine, but it works with quite small problems, beside quite small programs that we are creating, not with really big programs where, for example, they long for a long time, and also, for example, we are creating libraries. Then this approach doesn't fit very well, because it's not robust when we want to change a lot of things, when we change our mind and change the details that we have fit in already in our records. Also, in terms of abstraction and leaky abstraction, I want to mention unnecessary abstraction. And for me, the example of such unnecessary abstraction is the object class, when you have a method toString, equals, and hashcode. And I can tell you the story about the problems that we had because someone forget about overriding all of those things, or about the automatic conversion any object to string when, for example, we are concatenating them. So it's often a really, really big problem, but it's not something that you can get rid of very easily, especially that this is the object class and this is the root of hierarchy of the classes that you have. I would personally prefer to have the methods like supports printing with one method, or supports equality, even with the generic, to help and tell that my objects is supporting these features of our language. So when you are designing your object, maybe the good idea is to prevent inheritance when you don't think about all the rules that I mentioned before. And remember that allowance for inheritance is your design decision in your software. You should always decide what and how can be specialized, especially when you create something that is public and available for everyone to be used. So maybe this is a good idea to make some class final, even if the class shouldn't be final because you expect that someone should extend that class. Then make all the methods that you don't expect to be changed as final in your software. Personally, I also like the Kotlin approach, where everything is final by default, but you have to open explicitly the class and also the methods which are designed for being extended. Of course, you can use the all open plugin, but this is another story. And why I think we still using the inheritance so much in our software? I think this is because we heard about the rule called don't repeat yourself. And we often think about it that we should not repeat field groups in our system. We should not repeat behaviors. But the most important is that we should not repeat the domain concept, the specific terms that we have. And for such things, we should have only one representation in our system. But we have to be sure that if the same things, if you have different things and they look the same, but they are not the same, that you shouldn't, for example, create for them an abstraction, because, for example, you don't know how your software will be evolving, and you have to be really, really sure to create a proper inheritance structure. So maybe the question is the inheritance good call when you, for example, designing such software? I like the quote from children who very often say, this is the same, but different. And for me, it means that on some kind of scale, you should put all the things that are close to the same, put all classes that you want to design as with the base class, for example, and put them on some scale and look if they are close to the same. Maybe you can use inheritance. If not, if there are a lot of different points and there are only some options, some parts of the class which are very similar, maybe we should use another approach. Because remember that inheritance is also a form of coupling, and this coupling could be really tight, especially between the base class and the specific class that we have in our system. And yeah, so when we don't want to use inheritance, what we can choose? We can, for example, use decomposition. In composition, it's enough, for example, to take advantage of decoration and delegation to another classes. So let's imagine that we have our interface estimable. We created that because this is the abstraction that we want to create, and we have some task class which is final and implements this interface. It's not a problem that this is final, because the interface is the information, what is your abstraction here. So you can create, for example, the external duty class, it's your own class, and you are able to expose the estimate interface from that class, but internally you can take advantage of the task class or not, depending how you model your things inside. And that's why you should always first start with the interface, because in most situations, good interface, well-designed interface is good enough for solving most of the problems that you have in your system. That's why people very, very often say that you should prefer composition over inheritance, because it's much, much easier to untangle your classes or your design when you have only composition. Okay, with the inheritance, we very often link the fourth principle of object-oriented programming, which is polymorphism. Polymorphism is also a pattern in Grasp, and from Greek, it means many forms. So you can ask a question, what can have many forms? It's about one method name that brings us different functionalities in our software. So how we can distinguish between those functionalities if we have the same names? And this is because we have the type system somewhere in our object-oriented languages. And here, there are two manifestations of polymorphism. We have overriding, and overriding is when, for example, on some interface or in a base class, you have the definition of the estimate method, and somewhere deeper, for example, you create an external task and you override that method and write your own implementation of that method. And if you receive a task, no matter which type of task it is, but we know that this is a task, we call the estimate method, and during the runtime execution, the runtime will know which estimate method should be called here. Yeah, and this is connected with inheritance, with designing interfaces, and so on. But we also have the second manifestation of polymorphism, which is overloading. And overloading is when you have the same method name, but different parameter list in terms of types. So for example, you can create a task from some kind of sample, as example of something, some other task. You can create a task with name and labels, and so on and so forth. And this is the great way to use the same naming and simplifying your API, because you don't want to invent some fancy names for when you are adding new parameter to your method. This is also the great way how to add default values in your software, in the object that you are creating, in the library especially that you are creating, and in such way your API can evolve much better way. And let's look at the example. We can have the parameterless finish method that our project was started with. And here we create the moment of finishing the task from some static factory of time. And this is not quite good user because, for example, we can receive the information about finishing task from some, I don't know, for example, from some event, from some queue. And instead of creating the moment when the task is finished, we would prefer to have finish method with one parameter. But our parameterless finish method could just pass to the new method the default value that it has previously. And in the future, when our API evolves and everyone is starting to using our new finish method, this is something that we want to achieve in our software. We make the parameterless finish method deprecated and mark it for removal. And we tell for which method should be used instead. And in the future, this method could be just removed from our code base. But remember that overloading is not a silver bullet. If you have a better name, which in a better way express what do you want to achieve, the change is so different that you should name it in another way, then go with the new name. Don't stick with the old one just in sake of the compatibility of your object, because it could bring you less value than you expect. Okay. That's all the principles that I have prepared for you today. And now I want to leave you with some key takeaways. First, hide all the details. Don't write it if you don't really necessary. They are not necessary in your code base. Expose only necessary information in the object that you are creating, or in the modules, in everything that you are creating. Know the rules, know the principles. They are fit together. They make us write really good object-oriented programs, not just the data-oriented programs. But those rules are not enforced by any compiler. Of course, you can add some plugin, but normally these plugins are not added. So you should always think about those rules and make a decision, should I apply that or not? In most situations, you should apply them, but there are some situations where there is your design decision. And the last thing, don't just write your classes. Don't make it public because it always were public. Don't use, I don't know, records because everywhere in the system I have records. No, when you are fixing, when you are working on some specific problem, design the approach, design your system, design your class hierarchy, find the proper way if you should use inheritance, if it's good way of applying inheritance, or maybe the composition will be good enough. Always design the software that you are creating. Okay, that's all from me. Thank you very much. And if you have any question, I will be happy to answer them.
Hey, Dominic, welcome back on live stage. Very refreshing and different view on object orientation. I liked it. So
Thank you.
Maybe can you tell us, was Java always a priority for you on your development journey, or did that evolve from other languages?
Yeah, Java is my main language, and I was using it for most of my time, but I have some time also spent in other JVM languages like Groovy, a small episode in Scala, but I don't like Scala. And yeah, now I think the Kotlin is something which is really great. It fixes a lot of the problems, but for me, the biggest problem with Kotlin is that it makes most everything public, and this is really, really big problem for me. But now I think that Kotlin is one of the best languages available on JVM. But I understand that in some situations Java should be also be used, and yeah, we should always know the Java as the basic language on the JVM.
It's often the first one. That's why I ask. I'm also very curious about different work philosophies. Maybe you want to give us some insight on your workflow nowadays. Do you have any problems with COVID at your workspace, for example? Have things changed?
You mean about the pandemic, or you mean about only technical stuff?
Both.
Okay, yeah. Yeah, so Yeah, sometimes the problem that I find is that we often switch the languages, yeah, and sometimes we do a review or in Kotlin or in Java, yeah, and those languages are pretty different. Sometimes we have to apply another rules, for example, for review or even for our design. Previously, there was a talk about the, as far as I saw, about data classes, extensions method, and so on. Yeah, I personally see a lot of people are heard about, for example, extension methods, and they are overusing them. And for example, using the Kotlin, they are creating more going towards the data-driven approach where you are adding more extension methods. This is something that I see very, very often, and people are more overusing that. And for example, this is my new enemy to fight with during the reviews. According to the pandemic, I think the pandemic, of course, it was wrong, but from our perspective, when we have to switch from local working and remote working, remote work, I mean, it's something that changed our whole approach, and now we are more open, for example, for the conferences like that, and it's great. I'm happy to be here. Yeah,
and we are happy to have you. So, Dominic, thank you so much for the insights on your topic. Hope you have a great day and hope to see you next time. Bye.
Thank you very much. See you. Bye-bye.
See you. So, and after these first 3 talks, we will take a break of 10 minutes. You can use this to get some fresh coffee, maybe get some lunch, and also maybe check out our Twitter. You can see the handle right there. See you in 10 minutes. Stay tuned.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back, everyone. So right back to Java and our next guest of today. Her name is Amanda. She's developer advocate at Gradle, and not only she takes pride in clean, scalable, readable, and maintainable code, she also teaches these values since 2005. Welcome, Amanda.
Thanks, Benedict, for the introduction. It's really nice to be here. How are you doing today?
Oh, I'm fine, Amanda. Thank you. Hope you too.
Yeah, it's been a great program so far.
I also think so. Very good topic day. So would you mind telling us what we're going to learn from you today?
Yeah, so my goal for you today is for people to essentially spend more time and love on how they build their code. Part of building your code is part of every developer's life cycle of code. And sadly, a lot of us don't actually devote time to it. And so this is just a reminder that if you give your code some love and you build some love, then you'll really get some benefits from it.
Amanda, sounds like a very interesting talk and very curious to hear it. So without further ado, stage is yours.
Thanks, Benedict. Hello, everyone. It's great to be here. My name is Amanda Martin, like Benedict said, and my presentation is Give Your Build Some Love, and it will give it back. You can reach me on a whole bunch of different social channels. There's my LinkedIn if you scan it. I'm also on GitHub and Twitter. Twitter is probably the best way to reach me, but you can always email me if you want to. So what we're going to do today is we're going to go over what is Gradle and the overall structures of the build. And then we're going to go on to kind of the things that I really think people need to show a little bit more love and some of the pain points that people have over time. And one of those is Java versions. The next one is testing and kind of some of the best ways I like to do some testing, and then some dependency management, and of course, some tips and tricks on performance. First off, I know not everyone uses Gradle, so the quick intro, what is Gradle? And I like to start off with kind of an analogy with this. And with this is the evolution of things. No matter what thing you have, you almost always start with the core feature. And then after that core feature is established, then you start to add things to it, whether it's performance features, safety, or assistance features. A good example for this that probably comes to mind because we use them every day is cars. The very, very first car, all it can really do was accelerate and turn. If I recall, the first car didn't even brake very well. And then they added brakes. Now we have cars and they have a lot of those safety, performance, and assistive features. You can click lane assist and practically not even have to steer. You have the check engine light, and so that means you know when you need to take it to the mechanic to fix it up. We even have self-parking. That's an assistive feature. So over the course of the car's evolution, we had this core feature that's really evolved. Well, build tools are much of the same way in that in the very, very beginning, the build system would just compile, test, and then package up your jar file. And that was pretty much it. Those were the things that we only needed. But since then, there's a lot of things that the build tool has evolved to do. If you look at our build tool, we can do test parallelization, which is a huge performance issue. We have Uber jars, which is a very assistive issue. And so we've added these features with time. One of the things that I really like about the build systems with time is that they essentially continuously guide you. And especially if you're using a like IntelliJ, then you essentially get these tidbits that help you about what are you doing. And you could add things like test coverage and test to fail. And so those are performance issues where you can essentially benefit from the evolution of the build tool of time. Okay, so that's the build tools. Now, how does Gradle fit into this? So we are a build automation tool. And the thing I like about it is we are a very extensible configuration model. So that means we can take it and you can be as simple as you want, where all you can do is package and compile your code if you want, or you can make it so that you can do really crazy stuff. One of the things that most people use it for is that dependency resolution, though, because let's face it, we're using a lot of dependencies. We've come a long way since Hello World, and now some of the apps that I've seen have, 4,000 dependencies just in their most base iteration. And so that dependency resolution is a really important feature. And then, of course, we execute tasks. We've been around for a while. Since 2008, our brand has changed quite a bit. If you haven't known it, we are open source under the Apache license, and we're considered one of the most popular open source projects, 30 million monthly downloads, because we work in tons of ecosystems. We're here as Java developers, but if you use Kotlin, it's just a little offset for it. We also work, of course, inside Docker, just kind of you name it, and we might have a plugin for it. Now, all of this open source is really under the house of Gradle Enterprise, which is a great feature and is kind of launching the idea of developer productivity engineering. And so I'm not going to get much into developer productivity engineering, but it's what you really need when you're starting to scale your software. And one of the great things about having Gradle Enterprise over our open source is that they allow us to have build scans, which gives you kind of insight into what your build is doing. Which classes are taking longer, what dependency you actually used, a whole bunch of really good features in the build scans. And last, about the overarching, what is Gradle? There's the obligatory, we are hiring. Like everyone else, even the little prompt before this, we're hiring. So lots of good jobs with it. Now, one of the surprising things to me is, I started with Tom's Windows Manager back when I started coding. And there is a lot of people that use Gradle in many different ways. And so the way that I like to use Gradle is with the Gradle wrapper most of the time, because I can just package up my project and then I send it to somebody and they can use the Gradle wrapper, and they don't even need Gradle installed to do anything, to run my code, to build my project. The other way that I use it to kind of make the Gradle wrapper is with the command line. But most people use it with IntelliJ, and some people use it with VS Code. So how this looks is, like I said, it's a very extensible configuration. And so inside our language, we have a really dynamic DSL. And that DSL is done with either Groovy or Kotlin, which are very much like Java with a little bit of differences. And so you can use your Kotlin or Groovy to create a plugin, and then that will essentially make your build script. And that's pretty useful. So how this all fits together is, I like to think about it as you have these build scripts, which are in the Kotlin and Groovy, and that's what the build engineer or the build author writes. And those sit on top of the plugins. And the plugins fit in kind of an interesting way, because some of the plugins are inside the Gradle API native, whereas others are just part of our Gradle DSL. And then, like I said, the build authors can essentially make those plugins as well. And so those all fit together on top of the Gradle so that you can actually build your project. Okay, so that's what is Gradle. Now we're going to get into kind of the structure of the build. So when we're thinking about it, we know that there's a lot of dependencies out there. We generally have some repository like Maven Central, and we pull down the dependencies and place them into our code. And this has a lot of benefits because then we don't have to write everything from scratch. We can just use all of that prior work that other people had. Going back to the evolution of things, it's really important that we could take one concept and kind of use it and build on it so that we can keep on evolving. However, when we're pulling in those dependencies, those also have dependencies. These are called the transitive dependencies. And that's where things start to kind of break. And you've probably heard the term dependency hell, because sometimes you'll get versions that don't line up. And that's when things really start to break. Well, once you get to your code, then you also want to, compile, test, and publish your code. Now, this is kind of a cycle, because after you publish your code, especially if you're making a library, then that code too goes into the repository system and can be pulled down from other people. So even though your code has all these dependencies and transitive dependencies, it now becomes a dependency for someone else. And thus we have a cycle, and why it gets so complicated sometimes with time. Now, to put a little bit of terminology to this, we call the repositories and dependencies dependency management. The code that you are actually writing is called your build configuration. And then the way of compiling, testing, and publishing is the tasks that we have. And so going back to the evolution of build, we know that Gradle is an open source build automation tool meant for compiling, test, and publishing, and that we have a comprehensive and flexible dependency management. But one of the evolutions with things that I'm really proud of is, we're completely open source. And so people have come in and they've added plugins, and we've added this plugin framework. So now Gradle is this customizable build automation tool. It can do so many things, almost to a fault. One of the reasons why people steer away from Gradle sometimes is because you can do everything with it. And so you can make it easy by just following some example scripts, but you can also write plugins to do almost anything you want. Now, if you're new into kind of building software, and everyone started off generally with Hello World, and the first time I did it, I think I just used like a makefile to compile it. It's long ago, I can't even remember. But one of the base plugins that we have, and everyone uses it because it's so base, is the Java plugins. And so we start off, whenever you're building your software, that you want to probably use the Java library or the application plugin. Now, these plugins are both going to use the Java plugin, and that allows you to compile Java. And so this is one of the most used plugins. And the great thing is, if you use the application plugin or the Java library plugin, it automatically applies the Java plugin. And if you use the application, that's the one that I use most of the time. Then you also have that configuration for that main class. And you can move your main class around and whatnot. It's unique because it's customizable. But if you just use the normal terminology and the application plugin, then all you have to do is Java compile, and there you have it. Now, there's another one that I love, and that's the Kotlin plugin. So if you haven't used Kotlin, it is awesome. It still applies the Java library and the application plugin. It essentially just sits the Kotlin plugin on top of the other ones. And then you could actually code in Kotlin and Java if you want. So cool to have both of them right there. Really good for as you're iteratively going through a project as well. So these are some of the plugins that we offer as kind of the Gradle native plugins. But like I said, it's a very customizable system. These are the built-in plugins, and I highly recommend that you use those too. But in addition to that, there's also a whole bunch of community plugins. And these are plugins that are open source community authors and publishes. And some of them are used a million times a month, just like Gradle itself, whereas others are only used by kind of the build author itself, depending on the plugin. And to kind of pull those plugins in, you want to just put it in your plugin block in your build script. So I always recommend that you go into the plugin portal and see kind of what plugins are available, because most of the time, if you want to do something, it's already written for you, and you just have to figure out which one it is. So the overall thing of plugins is inside the plugin are the tasks to do things. And the task takes an input, does an action, and then an output. And so no matter what you're doing, you could think about it as it's all done in the file system with an input, action, output. Input is the code, which is in a file, and the output is generally like a jar or a zip. And so everything is broken down into tasks. And so to see one of those tasks, for example, here is the test task. And this is automatically applied with one of the plugins. And so we define kind of the directory of the input, and you can see that the test has a whole bunch of tasks associated with it. And inside those, you can see there's some dependencies as well. And so it's always nice to look at the task tree plugin. Now, these slides have a lot of links in it, so if you want to peruse later, that's awesome. There's also a lot of content in the slides that I might just skip over some. Now, when you're doing a task, you want to try and use some of the best practices with tasks, of course, which is why I recommend looking at the plugin portal or some of the default tasks, because depending on how you define a task, it can take a different amount of time to do it. For example, if you create a task, that means every time you are going to run that configuration, it's going to create that task because you said create the task. That's a problem because as you have more and more tasks, that time could add up. And sometimes your build can get really slow, and that's a pain point. So if you have any task.create, then change it right now to task.register. Register is much better because you're essentially just making it so that you say this task is here and create it if we are using it. And there's other ways of doing this as well. This register is really good for simple tasks, which is probably what most of us are writing. And yeah, if you have more complicated tasks than that, then there's probably a way to do it that's already done that you can go through the plugin portal and the custom plugins to see what it is. But okay. And another thing that we like to do a lot is the do first and do last. Now, this is an example of a delete test archive where you can see that it's deleting a file. Now, I have this as register, and so we're happy there, and it only does it if I execute this task. Now, this isn't the best practice, though, because this can also be done with the delete task. And so even though I made this, I didn't actually need to make it because I could have just used the delete task. But this shows you kind of how to use the do last command. It's really useful if you have kind of an order of things that you always want to happen. Okay, so now I'm going to get into a few tips as far as structure of builds go. I like to have this in my settings file because this way, every single time I run a build, it goes to the build scan. And this way I can see kind of what has happened over time. Everything I write is open source. It's not protected in any way. So I don't mind if, there's a URL up there that anyone can view. And it's really helpful because then if something breaks, I could take my URL and I normally put it into Slack and say, hey, help me with this. What happened? And people do the same where I go into Slack and I see their build scan URL and kind of help them troubleshoot their configuration problems and whatnot. And so I always add this into my settings.kts file. You can also do it via the command line with the -- scan. It's one of the best features of any build, so I recommend it. Now, one of the things that I talked about in my prompt is that you should be able to do any type of build, and whether it's a single project or a big, long multi-project build. And what this looks like is you can essentially link together your sub-projects. And I like the next slide a little bit more because this is what it actually looks like in a real build. And you can see that each sub-project here has its own kind of build definition. So we have the app project, and then we have the model project. And so each one of those has its own kind of customizable build. And so each one has a build file to tell me how to build it and what dependencies those are. Now, we can also have it so that there's one overarching build file. And with that overarching build file, the build src directory, then you can kind of define the build into other projects. And kind of how you set up your code is completely up to you and kind of what to be optimized. But you definitely want to think about which is best, having kind of projects side by side or having one ultimate build src that kind of rules them all. Now, the other thing that I found helpful that doesn't seem very well out there is whenever you're running these things, if you're trying to kind of troubleshoot, then you can have -- council equals verbose, and then you can see a whole bunch of things, way too much, but I kind of like seeing all of that so I know what's happening with my build. There's also -q, which is quiet if you want Gradle to just do its thing and you can focus on your coding. Both of those are very nice to have in different times. So if we zoom out at what the picture of the builds look like, this is kind of what you should see. We have the build author, which is oftentimes a community member, sometimes somebody in Gradle itself, but they essentially make some build logic, and that build logic is given into a file system. That's why it's a file, as the DSL, and that language is then taken via our configuration into the build model. Now we also have external plugins, and those plugins are also given into the build model. So all of that comes together, and they essentially make the entire Gradle project. Then you could take that project, and as a build user comes in, these are normally the developers, they will launch a task, whether it's compile Java or building a certain project. And so when they do that, they're accessing the task graph to see which operation they should do, whether it's build documentation, who knows what the projects are doing. And then that task goes to our execution engine, which then executes the task, assembles the zip or whatever you have them do. So this is kind of how the two users are separate, and they both contribute to the overall entire ecosystem. Okay, so now on to some of the pain points people have with it. One of the largest pain points is Java versions. So many times the Java version that you're using doesn't match the Java version that you want to use, and your Java home, and everything else. And so one of the important things is that you have a consistent, reproducible build. If you ship this project to that build user, you want to make sure they can actually build it. And so you want to make sure that you have the correct Java version. And of course, sub-projects might require a different Java version. So some people like to use Puppet, for example, or virtual images for this, but does that actually ensure that we have the correct Java version? I don't think so. So one of the ways to do this is in Gradle, we have something called tool chains. And the tool chain is going to allow us to essentially define the Java version we want to use on the project. And so here you can see the code snippet. We're using Java. We're going to use the tool chain class, and we want to set the Java version to be 11. And so that's a really nifty feature. But where it really comes in handy is we can also do that for each task as we want. And so there's an example that I really like where when you're looking at, I think it's a common lang 3, they change how indent is used into the new version. And so if you use the system print message.indent, it actually breaks for one Java version and not the other. And so it's kind of a good test, manual test, sorry, but I do like those, to see which Java version you're doing and having things break. And so here you can see that for this task, I'm using 17, and for yet another one, I'm using 18. So it's a way for you to kind of cross up which Java versions you're using. So that is tool chains. If you haven't defined your Java version, you should. Now, next is a really big topic, and that topic is testing. With the concept of TDD kind of really well set and established, there's some projects that have 5 lines of testing for every line of code. And we have this testing pyramid, which I know a lot of you have seen. But the idea is that we should have a lot of tests. The problem is that some of the tests are really, really slow. Especially when we get to the end-to-end testing, it could take a long time. There was one user that I saw that it takes 15 hours to run their test suite. That was just, wow, 15 hours. I couldn't even imagine writing that much code to test. And that was on a really nice CI machine. So what we decided is a good solution is to split up the tests so you can run different tests in different times. Those unit tests you should be running more frequently than those end-to-end tests. And so we want to separate the code or separate the test based on kind of their use case. And so we have the unit test that we run more often, and we have the integration test and maybe an end-to-end test that we don't run as often. So this is something that isn't a new idea. You've probably seen it before. And the way that we've always done it by hand is, you create a source set. This is the source of the things that you should be running right now. And then you configure each one and you set their class paths, and then you create the custom tasks to run this set of integration tests and this set of unit tests. Well, that's all fine and dandy, but it was such a common use case that we decided to essentially do something for it. And so we have the JVM test suites. And so this is a plugin. Notice a pattern there? Everything is a plugin, right? So this is a plugin where all you have to do is apply the JVM test suite plugin. Now this sits on top of that Java plugin. And so if you're using this, then you must also have some JVM plugin installed, whether it's Kotlin or Java, because it essentially builds upon it. So to use the test suite, what we're going to do is we say testing suites, and then in this one we have val int test, and so that essentially makes a source set of int test, and then registering, again, we only do it if we need to, the JVM test suites. And so now we have a task, we have a source set, and then we're doing an implementation for this on the project. So what that'll do is it'll take it. So now we have an integration test that is separate from the other ones. I highly recommend it. I don't think I linked the documentation on this one. Whoops. So if you need the documentation for that one, let me know. Now, the other thing that's really important that a lot of people are doing is test coverage. And so especially with TDD, they want to make sure that all the lines are actually covered. And the best plugin for that with the JVM is Jacoco. So this is something that we didn't write, but that is well used, and so we have it now part of the system. And it works with all the JVM languages by looking at the bytecode. And so the way that we normally use it is we have the Jacoco plugin, and we have some type of verification on it. And so in this case, we're looking at the line covered ratio, and we want to make sure that the coverage ratio is 90%. And so if it's anything less than 90%, then that means this test will fail. If it's greater than 90%, then it will pass. So we can actually set it so that if our coverage isn't high enough, then the entire project fails, which is kind of cool. 90% might be a little high, but this is a really aggressive way to do it. Now, this isn't really testing, but code style is really important, and it helps spot a lot of bugs. And so some of the plugins that I like for it is for Java, check style, Groovy Code Narc, Kotlin, detect. And even though that these are not necessarily part of, our native system, they're also really well maintained because it's a strong community. And so if you need to see kind of how the code should be styled and whatnot, these are the ones that I highly recommend. Okay, the next big topic is dependencies. And this is where a lot of people end up throwing up their hands and kind of giving up on how things are done. The Gradle solution to dependencies is something called the version catalog. And this is a new thing. It's just in the latest version of Gradle 7. And it's kind of a centralized spot for you to keep track of your dependencies. And it is really awesome because you can essentially have one spot and then transfer that everywhere else. And so this is a TOML file, which is a little bit different than all the other DSLs we have, but it's also easy to read and kind of navigate. And it keeps track of the versions, the libraries, how you want to bundle your things together, and then the plugins that you want to use. So to see that in practice, this is one that is stolen from somewhere else. You can see that we have a Groovy version, the check style version, and then the libraries that we're using, Groovy Core, JSON, and NIO. And notice how it specifies the Groovy version from above. And then we have common length 3. It's in almost everything I use. And we define the versions that we want. And I'll go over what these kind of mean in the next slide. And so we're bundling up all of the Groovies. If we're using one of these, we use them all. And then we're using a plugin and the version. So now that I have these, if I wanted to use kind of these libraries right here, all I have to do is put them in my dependencies block. And there they're used. This is a lot cleaner because now I don't have to give the full coordinates for those. All I have to do is list them. Libs means from the the version catalog and then pull out what it is. And notice that it automatically converted the dashes to dots, so it looks very pretty. I have all of these as implementation. One of the things that tricks people up a little bit is that there's different types of configurations. There's the API and there's the implementation. And so most of the time as we're making things, we're going to be using the implementation configuration. However, there is also API. And the best way to think about it is if you are doing something that is public facing that you need people to interact with, then it's going to be an API. But if it's something that's internal, then it's going to be implementation. Most of the stuff that I'm writing these days for fun is implementation, so that's what I use. And then there's runtime only and test implementation, which of course is runtime is when you're actually running the application, and test implementation is for the actual test. We have a really good example on our website about kind of the differences, and if you change the API implementation to API to an implementation, then it actually breaks the build. So it's a kind of fun one to walk through. Now, as far as dependency versions, you saw all of the kind of weird ones with the common lang 3. And here's kind of some of the rules for it, where this means version 2.3 or later. If it's 2 exclamation mark, it's strictly. The plus is the latest. And then, of course, we can use a snapshot if we want, which I don't recommend too much. But, of course, having those versions there is a very dynamic thing. And it'll cache some of the versions, and you could change, of course, how long it's cached for. But if you have 2+, then it's going to be the latest version. Every single time a new version comes out, then you're going to get that new version. Okay. So you can see the dependency resolution in real time, though. If you look at it and look at the dependency tree, here's a good example where I directly define the implementation dependency of Guava 31.1. Now, Juice, of course, uses Guava. And so here you can see Juice, it says it wants to use Guava 31. Now, since we have a direct definition of 31.1, that dependency is actually overridden to 31.1. And so our transitive dependency is updated, which is kind of nice because that means you only have one version going around, which is less problem shooting. Now, like I said before, you can share this catalog. And so if you make one catalog and you want to kind of share it to a different project or have it in a multi-project, then all you have to do is take it and essentially reference it from somewhere else. It's pretty slick. Okay. So lastly, we have performance. And of course, performance is a really big one. And so a lot of time is going to be spent on this. The first way to do performance, of course, is with incremental builds. Now, this is something that is really useful, and you've probably already seen it if you've run any of our Gradle tasks before, because an up-to-date build, you'll see an incremental build, you'll see the up-to-date option automatically applied when you're running that task because it pulled it from some cached resources. So there's a whole bunch of other things that we can add to this, though. And one is the build cache. And so here's an example from Spring Boot. And they have the duration as 20.25 seconds without build cache. And this is one of the things that things start to build up. And we've all seen the XKCD joke, get back to work, compiling, oh, carry on. That's something that is a real big pain point for a lot of developers and something that we've tried to fix. And so we have this build cache. And with Spring Boot, just by applying the build cache, they were able to reduce it to 3.22 seconds. They did some other optimization that made it better, but just with using kind of the out-of-the-box features that I'm talking about here, they were able to reduce it that big, huge amount. Okay, so what is build cache? Essentially, you have a local place that is storing all of the outputs for your build. And so if you're very incremental in your development, then you probably change, a few things at a time. You build it, see what happens, change a few things at a time, build, see what happens. In my case, I go back to how it was before because I broke something, build, see what happens. And so I'm starting to build a local cache for all of the inputs. And those inputs are stored as the output on my disk. And so when I'm running something, if I've already ran something similar to that on this certain task or class, then it'll pull it from that local build. And so to add this to your build, all you have to do is add the -- build cache flag, or inside Gradle properties, this is how I have it, you have org.gradle.caching equals true. And so it'll automatically just pull it from that local build. Now, sometimes there's some cache misses and you want to explore why. And in that case, you can essentially kind of look into the build and look at the SHA to see why it built and why it pulled from the build cache and why it didn't. So that's the build cache. Now, there are 3 life cycles for a build. Build cache is the final one, of course, and we have the configuration. And so the configuration cache is another thing that we started kind of working on. And this is not yet stable. And so that means you have to opt into it. And you actually have to put inside your settings.gradle file that you want to kind of preview what this looks like. About half of all people that I've seen actually building software are using this, though. And so I highly recommend that you try it, because even though it's not fully stable, it's pretty close. One of the developers says that their company is saving 5,400 hours a year by using build cache. So it's pretty impressive. And in the Gradle.properties, you add this line where I like the warn, so it warns me if there's a problem. But you can see that here is some runs and then runs with configuration cache, and the drop is amazing. And so definitely add these to your build file so that you essentially stop sitting around waiting for the cache. With the configuration cache is, if you don't change your build, then the entire configuration is cached. And if you're just a developer, then you're probably not changing your build at all. So that means this is going to save you a lot of time. So even though in my graph you can see that there's still some time with that configuration, if you're not changing your build, then configuration and cache, and you just pull it from that. Okay, and so another feature that I like that helps with performance is this continuous flag. This is awesome because if you change something, for example, if you're inside your Java code and you're changing a method, as soon as you change that method, the file system monitoring will see that you changed that method, and then it'll essentially run the task that you had last run in the background, like compile Java. And so this is really useful. For example, if you have a program and you want to see it update in real time, you have continuous there, and then automatically you can see the effect. Now, this doesn't fit every use case. If you're doing big, huge changes, then you probably don't want the continuous flag because you'll have a lot of things running in the background, but it's really useful for kind of testing things out. The next one that is not enabled by default, but something that you probably want to add, is the parallel execution. And so you could do it in the command line, of course, but I like it in the Gradle properties again. And one of the reasons why I like it in Gradle properties is because I could always comment it out if I went later on. And then normally I run these actually in IntelliJ, but then I don't have to actually change the task when I'm running it for each time. So the parallel property, it is only between tasks of different projects. So this is one of the things to think about whether you have kind of the side-by-side projects or one big project, because the parallel only works on the different projects. There is some pitfalls with this, and that is if you aren't really thinking about how the projects work together, then you might have some build logic failures that don't necessarily function out well. Okay, and one of the final ones that I really like is the profiler. This is kind of when you're in the last phases and you want to see how things are running and how you can speed up things. And this is one of the things that generally I will do as the last step to kind of improve things with time. And here's kind of the performance.scenario file for it, where you go in and you're doing your task to see what happens with the task. You want to clean in between the tasks so that you have essentially a fresh task each time. And then you're adding in these non-ABI changes. And so what that means is that we're making changes and they're non-ABI, so that means the application binary interface is not changing. And so you can essentially, if it isn't cleaned, it would essentially pull an up-to-date task. And in this case, we're doing a version comparison of Gradle, where we're comparing version 7 to 7.4.2. But the Gradle profile is good because at the end of all of these runs, you can set how many runs you have. You can see how long it took for each one to run. And this is both an HTML and a CSV output, so you can really get into the nitty-gritty details. But you can see the blue line is going to be one version, and then the red line is another version. So you can compare those two benchmarks. And if you want to really get into it, you can start looking at the flame charts and the graphs for this to see what is taking up most of your time in one version versus the other version. Now, these flame charts are really awesome because you can zoom in on them and actually read each one of these classes. Okay, so that is kind of all of my tips and tricks and suggestions as it comes to Gradle, how to structure Gradle, the versions, the testing, dependencies, and the performance. So I am here if you have any questions. Of course, reach out to me on the social media platforms. I really like to talk to developers, and so if you actually want to set up a time where we can meet and talk on Google Meets, that's also awesome too. I'll send you my calendar link, and we can have a discussion on how to optimize your build.
Hey Amanda, welcome back on live stage. Thanks for the talk.
Yeah, of course, Benedict.
I thought because you have so much experience as a teacher, you taught on various colleges and schools, maybe let's jump back to the first talk where the question came up on how to introduce kids to programming. Maybe you have some insights there for us.
Yeah, so kids in programming is always one of those tough things because coding could get really hard. And I showed a lot of code snippets that are pretty in depth. And I would say that it really depends on the age of the kid. You know, I like to start kids as early as 5 or 6 in something called Scratch Junior. And I don't know if the audience has heard of it, but Scratch Junior, it is essentially like a block coding that you drag and drop stuff into. And they really like changing the colors and things like that, which is kind of cool. Now, a little bit older, middle school age, it's nice to start to do Scratch, where they can make, virtual cards that have loop behavior in them and things like that. Or if then, as one character moves, have another character follow it. So you can start to get into some of those algorithmic thinking. And then about high school age, it's really good to do stuff like Arduinos. And Arduinos are nice because they're flashing lights that you can add with a little bit of code. And so it's a lot of benefit. And so you can change the amount of flashing. You can have an RGB that changes the color. There's a lot of code automatically that you could download. And so then you're starting to get them into reading code, because a lot of the skill set that they're going to need is that reading and that understanding of the code. And so definitely don't just drive them into writing for the first time.
Yeah, I can also recommend the Arduino. I also got a bit into it in my time at the college. And as a teacher, you surely also have some more general resources you can share, also with more experienced programmers.
Yeah, so for more experienced programmers, I always think that the best thing to do is just to have a project in mind and give it a try. Even right now, we have a mentorship program where we're taking kind of mid-level software engineers and we're trying to move them to their next phase of their career, into that kind of senior level. And even those, it's really nice to have a concrete, here is a project for you to do and take that to the next level. It's always good to go on MIT Open Software and kind of do that learning, go to YouTube and see what that learning is. But if you don't get your hands dirty, then I think you're not actually learning the tools. And so, you probably want to start off with, of course, that hello world, and then start challenging yourself. I think the next one that I did after that was Pong, of course, where I had to integrate with Java FX and go from there. That's a really good one as well if you Java is a little tough to swallow for students also. And so I know we're here on Java Day, and I love Java. I do. I love Java. But JavaScript on top of processing Java script is really easy for students to enter. And so after the Arduino phase, it might be really good to show them JavaScript with that processing JS on top of it, because then they can make that Pong game and something really easy. But having a concrete project in mind is really important. Now, projects can be too hard though. And if it's too hard, then a student can be demoralized. And so it's really useful to kind of find someone that's a little bit better than you or a lot better than you and talk to them like, here's where I'm at now. What project would you recommend for me? One of the things that I love about software is it's filled with a lot of introverts, but they're really useful and helpful. And so if you reach out to one of the people that you work with, reach out to me, then we could point you into like, here is a project that I recommend that you try. Here's the fully functional project that you can see as your end result, but make your own solution to get there.
Right. Thank you for that insight, Amanda. We got a Gradle related question as next. Should we use only Groovy for writing automation for build tasks?
So Kotlin is actually really popular right now, and it's one of the things that a lot of people are switching to. And there's, in probably 5 years or something, Kotlin is actually going to be the default for Android and other things like that. And so there is no problem with writing it in Kotlin as well. Sometimes there's a little bit of a performance hit if you write the entire project in Kotlin, but if you're just doing your tasks, then Kotlin is a-okay.
Right. Amanda, you're a developer advocate, so I don't think there is no such thing as a normal workday. But if you have to describe like your weekly schedule.
Let's see. My weekly schedule is I spend about 30% of the time on technical content, and so about pulling up my IntelliJ and coding out some solution. I probably spend about another 30% of the week actually interacting with developers, one-on-one. Let's talk with Calendly. What are you doing? What's your build look like? How can I help you? And kind of getting that user feedback about where we can go. And then I spend some of my time like this doing presentations. So a typical day is just kind of interacting with people as I try and sneak in some coding.
All right, Amanda, thank you so much for the awesome talk.
Yeah, thank you, Benedict. It was great to be here.
Awesome. Hope to see you next time as well.
Yeah, have a good one.
Good. Bye.
Bye-bye.
All right, and before we jump into the final part of the topic day, we get into another 10-minute break. Stay tuned.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, everybody, and welcome back to the final part of the topic day. Now, for the last talk, we have another amazing speaker invited. His name is Gil. He is the CTO at Testing Gil, and with more than 25 years of experience, he's a real expert when it comes to methodology and practices in software. Welcome, Gil.
Hi, and great to be here. How are you
Hi,
today?
Gil. Yeah, awesome to have you. So please tell us what we are going to learn from you today.
Well, I hope you learn a lot, but this is only a 45-minute session. So this is a session about how to apply clean code principles to automated tests, something we don't do as often as we should.
Okay, so very important talk. Gil, without further ado, stage is yours.
Thank you very much. So like I said, it's great to be here at WeAreDevelopers. And this is not my dog, unfortunately, but at least he keeps clean and after his stuff. And basically, this is what the session is all about, how we can clean up after our stuff. Hopefully it's not that messy, but sometimes it is. Who knows? So hold on. Yeah. So short introduction. I'm Gil. I come from Israel and I've been in software, I don't know, since age 10, something like that. My day job is being a trainer and consultant with developers and testers and everyone in between. And I hope to help everyone who wants to build better software. And I'm the author of the books, Everyday Unit Testing, Everyday Spring Testing. The examples I'm going to show today, obviously, are in Java, but whatever language you to use, the principles are going to be used the same way there. You can get in touch with me at gil@testinggil.com or at testinggil.com or Everyday Unit Testing, which redirects there, or on Twitter, which is sometimes I live there as well, and that's basically me. So people ask me, Gil, do you write clean tests? And the answer is, I really try. You know, it's very hard. Why is it hard? Because, like, I don't know, a couple of days after I've written any code and test, I look at it and it basically looks like this. I basically look like this. Code also. And there's a reason for that. And we talk about code. Code doesn't change. We change. So whenever we look at the code, I don't know if you've written something like a blog or a piece of music or a painting. Every draft is, we look at it like that because we know we're better. We've learned over time. And if the code stays like that, we kind of look at it and say, well, this is the best way I could have left it. Well, we probably could have done more. But test code is a bit different. And the reason it's different, again, it's not that the code itself is, but the way we treat it. Test code and production code, we treat it differently. And there's a couple of reasons for that. First of all, we know it's real code, but we don't treat it as real code. That's like it's not production code. Support code. So already we look at it a bit differently than in regular production code. But there's a bit more to that. When we develop code, we know that we're going to go back to it. And so we try, if we have like some clean code standards, if we don't have any clean code standards, we just leave it as is, but then we don't do the face. But if we do, we cannot try to keep it in a certain way because we know we're going to get back in there sometimes in the future. Tests are not just like that, because once an automated test passes, it's way back in the past. Because we kind of think, well, what are the chances that we just go back into this test? Obviously, the chances are high, but our brain doesn't consume in the same way. So if we don't go, we're not going to planning to go back in there, it deserves a little bit attention. One more thing we do is that we write it a bit differently, and that is, once a test passes, we kind of copy and paste it and modify it. This is not like regular code development, but if we don't take care of to cover our tracks and refactor along the way, we'll see that. And I'll show you today in the examples how it looks like. So you can see that. And once we duplicate code, we duplicate a lot of the code smells and the noises and the garbage we don't like to see. So there's a lot more of it. And basically what happens is that we don't apply the same standards. For a lot of teams that I work with, do code reviews, but either they don't look at the tests or they just look at them to see if they're passing, something like that. Again, it's not the same standards as we apply to regular code. Unless, of course, like I said, if you don't have any clean code standards, these are exactly the same standards that you apply to tests. Now, most developers that they talk to kind of agree that their job is this. Code that works over and over again. Code that works, we understand. Yeah, we have tests for that. We have documentation. We know if it's working or not. The over and over and over again, that's mostly not measurable. If we go back into that code, we want to spend as much as we can working on the new stuff rather than old stuff. And everything around clean code and automated tests, all the processes that we have to spend less time on the maintenance part and more on the new stuff, help us there. So we know in our minds that it will help us. Tests help us, clean code help us. Obviously, clean code in test will help us. But again, we don't look at it the same way. So we need to change our mind, the way we think about it. So that's one thing, but let's talk first about what is clean code. Now, I teach clean code a lot of work courses and workshops, a lot of demand for that. And there's also always that discussion about what makes code clean. There's not one definition. But I'm going to start with what I think. And it goes back to what clean code does rather than what it looks like. And basically, it's about time. Now, what happens? We write code now. It works, the first part. When we go back into that code again, we want, like I said, to spend much as we can on new stuff, new exciting stuff, not on code maintenance, not on bug fixes, not on anything that is boring. Even writing tests can be boring. We don't want that. We want to work on the interesting stuff, whatever interesting is for us. For developers, it's mostly working on new code. For testers, we want to work on testing the new code as well. So the more we invest now in things that can help us and spend less time later on maintenance, it's worse for us. And clean code and clean tests fall into this bucket. Now, you probably seen this kind of comic before about what makes code clean, or what is better code and good code. And the truth behind this comic, it's really in the eyes of the beholder. So when we are finished writing our code, like I said at the beginning, we're sure this is the best that we can do within the time, the limited time, and what we can do, because otherwise we would improve it. At that point, we said, well, it's enough improvement, it's good enough. Obviously, it's going to be good. It's good enough for us, going to be good enough for other people as well. Even our With the other people are us in 3 days. But we need to get other people's ideas in. So we need to know if it is good enough for them. And this is also not the final point, because like 3 months from now, we or them need to go into that code again. They're going to look at the code and say, well, is that what I get? What did I do to deserve this? So it's really a question of also of how far we are from the last review of the code. So there are a lot of phases in that. So here are a couple of quotes of what makes code clean. So from people who actually know about software a lot more than me. So Grady Butch, one of the main big thinkers behind object orientation. So the clean code is simple and direct. It should be written like prose. And that's like I ask everybody in clean code classes like this. Look at your code. Is it written like a book? Is it written like a story? Can you read a story from that and understand what's going on? Now, the beginning, the people will say, well, of course, like I wrote it. But does it tell the story of the system, of the workflow? Does it use domain names, stuff like that, that will make things easier to understand or to apply? Remember, code and test code, it doesn't matter, is a model. It's a translation of a design model, which is a translation of the requirement model, which is different than what the customer actually wants. So it's already a translation of translation of translation. The less translation errors we do in the middle is better. The more we use the same language in the code and in the design and in the real world, like the domain language, it will tell us the story of what actually is happening here. And we want to test, by the way, to speak at the same language as the code. Michael Feathers wrote a very good book on unit testing. It's called Working Effectively with Legacy Code. I think it's the Bible of unit testing for me. His clean code always looked like it was written by someone who cares. Like, cares about what? Cares about other people and cares about other people's time. Again, if I write something not for me, if I know that somebody else will use my code, I want to make sure that he benefits from this and does not waste their time and do not make any mistakes wandering around this code. Because I've written it under some assumptions and in some language and so on. I want them to get the same picture because I care about their time as well. A few years ago, I think it's now 10 years now, I think, I was in a workshop of test-driven development in an assembler language, like zeros and ones almost. And we wrote code there. And I think like an hour and a half after this, I looked at the code and I didn't understand what it was doing. So computers still ran this code. Computer doesn't care. It doesn't care about how the code which translates to zeros and ones look for and who's going to read it. If it's working, it's working. It's not working, it's not working. Computers are very oblivious to that. But programmers write code for other programmers, and then that's not me who said it. That's Martin Fowler. Martin Fowler is one of the people behind the Agile Manifesto. Had a whole wiki devoted to code smells and refactoring, and he wrote books about it, so he knows what he's doing. So basically, if we're doing this, we want to apply this to the code, and it's not any code, just production code. We want to apply these things, the idea behind these things, to the tests as well. And what does it mean? So I chose a couple of things here. You probably could add a couple more, but there are things that are like relevant to test a bit more. And the first thing that they show intent. Everybody knows that automated tests are basically examples of how to use the code. If it's in the unit level, what the component does. If it's the end-to-end level, what the system does. We want to read the intent of this test, because we're basically running the system, whatever the system is, in a specific scenario, and we want to know what the end of the scenario is. And we want to read that from the test. We obviously want to run the test and know if it works or not. But if it doesn't, what we'll go first is look at the test itself and try to understand, why is it not working? What does it do? What does it assume? We want to see that. And that's the intent of the tests. So basically, it tells you how to do that. If we can't get that from our tests, probably the test can be improved. Good tests or cleaner tests are focused. And usually this comes from a unit level talking, but it's not just that. So let's assume that we have a class and we have a unit test for that. So that's basically, you see the interface, you see a couple of methods. A class usually, hopefully, doesn't do much. And therefore, you'll read the test specifically what it's doing. And it's very focused. And if it fails, you know what the problem is. But it doesn't have to be. It can go like to API tests, end-to-end tests. The same thing. They may operate bigger systems and bigger pieces of code, but they're still doing something. And if they're doing a lot of things, that's a problem. That problem is that for us, again, we're reading it, we don't understand what it failed on, what was the assumption, if it failed on step 4 in the workflow that we're passing, like the 4th API, we need to know, first of all, what came before it, what was the state after stage 3, and so on. So the more we focus the tests on smaller stuff, whatever small is, we understand it better because it tells a smaller, more focused story. Again, it fails on that problem with that story. If you know, there's what we call in clean code solid principle. So these are principles from object orientation that could be good practices to do. One of them, the first one in solid, is the SRP, single responsibility principle. SRP tells you that a class should be doing one thing and one thing only. If not, you should separate it to different classes. It's basically the same thing, but doesn't have to be on a unit level. It could be like other things, like a single scenario or single workflow. A single workflow can be multiple APIs. That's okay, but it's one. Is brother or sister test will take another scenario. That's one of the things that we want to see when things fail, is that this test passes, but this one doesn't. Like we know that this failed, but how is it different than this one? And the first thing we do is we try to look at the tests. And the quicker we have to understand what's the difference between those things, we'll solve the problem quickly. Obviously, if everything fails, probably there's a setup or thing or something like that. Usually that's not a problem. Usually it's one failure, but other surrounding scenarios around it are still working. And we'd like to know what the difference is. The final thing kind of leads to how code is written these days, and that's for all code. We don't write everything from scratch. We use a lot of third-party libraries. We use Spring. I'm going to show you an example in Spring. A lot of frameworks, a lot of libraries, and a lot of the code we write has different levels of language in it. Let's take JUnit or Spring. Doesn't really matter. Basically, both of them are frameworks that are general purpose. They do what they do, but they need to fit everyone who writes Java on the planet, right? So it could be for finance application developers, and it could be medical application developers, and it could be, I don't know, Twitter application developers. So they don't know who the target audience is. They speak that language. However, when either finance or medical or Twitter application developers write things, they have language in their domain. They're using in Twitter tweets and replies and stuff like that, and we'd like to see those in the code. But we're using other frameworks, right? So what happens is that we have different kinds of languages inside our code. Remember, Grady Butch said it should be written like prose. Have you seen a book that's written in 2 different languages, interleaved? It's kind of hard to read. So we want them to speak the same languages. And one way to do that is abstraction. When we abstract details of implementation or details of use behind adapters, something like that, that speak the same language. So when we have these kind of attributes to tests, they become a lot easier to understand and less prone to errors. And we'd like that. Now we have what we say code smells. And like I said, Martin Fowler has a big bunch of list of them. Code smells basically are patterns in code or anti-patterns that tell you that maintaining the code is going to be problematic. It's not telling you anything about whether the code works or not. So we have things like that, and I'm going to go a couple of those in this session that I apply to test as well. So the first one is God classes and methods. God classes, basically very big classes. God methods, very big methods. Now, in tests, we have a separate case of God classes because test classes are containers which kind of gather around a different setup and cleanup. But we can, basically we think if they have the same setup, let's just fit them inside the test container and everything will be okay. But we kind of create giant test classes that we don't know, well, what should go in there and whether my test fits in there or not. And again, this is about time. If I now have to add another test, I will spend more time understanding, well, where does this go? Whether if there were smaller test classes, they were more separated by functionality, workflow, whatever rules we decide, it would be easier. I will spend less time on that. God methods, big tests. We've seen them. We don't like them. It's hard to understand what they're doing. Comments are very interesting because you think, well, I may not have seen a lot of comments in tests. Well, first of all, they are used in tests, but we have other kind of comments called test names. Comments, the problem with them as a smell is that sometimes we just change the code and forget to change the comments. Sometimes they're not useful. It's basically the same thing with tests as well, and we want to get rid of them. Uncommunicative names. You'll see I'll show you examples of how test names can be problematic. Remember that when a test fails, the first thing you see is the test name. If it doesn't tell you how it's different, and like I said, not by itself, how is it different from other tests that do pass? They can be better. Final thing is how we use constants and literals in the code. I'll show you a couple of examples of that, but keep in mind that if you've seen like a test uses a user ID equals 17, that's all you know, that user ID is equals 17. Did you ever think about, well, what's special about 17? Is it the same as 18? Or is it different than 18? How do I know this kind of information from the test? Because otherwise I'll need to run and debug the test and understand what's the difference. So I don't want to see like different numbers or magic numbers, we call them, in the test, specifically because tests are about different certain scenarios. And this 17 means something. So we need to know, and at least we can give a lot of clues around this thing to the reader about what's going on. Okay, so I've talked enough. Probably want to see some code, crashing code maybe. So let's jump into IntelliJ and I'll show you a couple of class examples. Okay, so I'm going to show you API tests, and these are Spring tests. And basically, what you see on the screen right now is a calculator controller, because all examples go to calculators, of course. But really, what the code itself does is not really important. Well, it's interesting that it does how it works. So it has like a root for the request, has a post mapping with called calculate. You can see the rows here. What you also can see that has a post method called calculate, and it gets a calculator params in the body, and calculator params basically is a data object. First, second, and the operator. That's basically it. And after that, it does something with it, like plus and minus. Doesn't really matter, because we're not going to look at that anymore, because we're interested in the tests. So let's close that. I'm going to start here. So this is my dirty test. So what do I have here? So first of all, I have a test ed, which is a very good name. I worked very hard at it. And you can see what's happening. First of all, there's a comment that tells you exactly what's going to happen here. Check that we can add two numbers that return the right results as a string. Wow, a lot of information there. Okay, what else? So we have a test add. We have something that builds the calculator params, 3 plus 4. And then a bunch of code here that creates the request, headers, and take the calculator params and turns that into a JSON and creates the request and uses REST template because this is old code, and then does the post and gets the result, and then it checks that the result is 7. Excellent! So good that I decided that this is good enough for a second test. And the second test, I copied it because that's what we do. I couldn't call it test add, so I call it test add minus. And you can see that the only difference is that I'm sending negative numbers here and checking the result here. But this is how we do stuff. We copy stuff and modify what's different, only we duplicate a lot of code, including this comment, which is still true, by the way, but that gives you a hint that probably not that helpful. Now, the third test I had copied and pasted, of course, and modified a bit. This does something with the minus. I call it test minus, and I've had enough of the old comments, call it subtract numbers. And this is a very good starting point to an example that we see a lot, right? A lot of tests look basically the same because we're starting with one and copying the others without refactoring them on the way. So what we're going to do is take this start as a starting point and then refactor those to better tests. The first one obviously is duplication, but first I'm going to talk about duplication in different ways. And the first one is, you can see that all the variables, because I copied them, are created and recreated here. So we can create a common setup like this. So in a common setup, we have these things as fields. There's a pattern called extract field. That's what we do here. And these fields are initialized in the setup itself, in the before each method, and already things are getting smaller, and that's good. There's something else about the setup, like the common setup. If everything is happening the same over tests, and one of the tests is failing, the problem is probably not in the setup. On the other hand, if all the tests are failing, chances are the problem are in the setup. So it kind of helps us by separating this stuff, to putting common stuff in a separate place, to, again, when something fails, solve the problem more quickly, because we can do some kind of Sherlock Holmesing in our mind, saying, well, where the problem is, some kind of a divide and conquer of where the problem is. Okay, so that's the first step. It's cooler. Tests already smaller, which is good. Remember, test fails, we look at them, we try to see what the difference is. Remove the common stuff, everything's good. But obviously, there's still a lot of duplication. But again, when it's smaller, you can see the comments. Actually, comments are duplicated. And let's pick better names. Okay, so better names. So I removed the comments and called the first one add two numbers and calculate result. The second one add two negative numbers and calculate result. And the third one subtract two numbers and calculate result. You already see there's duplication in the names as well. I'll try to get rid of that in a moment. But we can, a lot of the times we kind of have this, do this and we'll get the correct result. Do this and get the correct result. There's no need in saying we're going to get the correct result unless we're being a bit more specific than other tests can differentiate these things. So get rid of noise. Every piece of noise that doesn't help us really hurts us in the time we're spending there. Okay, that's cool. Yeah, we can still see the duplication, right? This calling the request part is really something that we're doing over and over again. Don't need that. Let's extract it to a method. And now our tests are becoming very thin. They have really what they have in the difference between them. That's very cool. You can see the method here called calculate, and it gets the URL, which at this point I saw, well, this is the same URL for everything. So we'll take care of that in a minute. But before that, I want to mention something else. What was that something that I wanted to mention? Okay, we'll get to that in a minute. The thing is that when we have this kind of duplication, we want to make sure that what we see are really the different parts, and that's cool. So that's okay. Let's remember this thing here. It's basically the same thing. So I can extract a constant out of it. But well, let's see if we can do something more. So first of all, I don't need to pass this as an argument. I can just use it as a constant. So it's in two steps. First of all, I extracted the constant called local URL, and I use it here. And I don't pass it as an argument anymore. Why? Again, noise. I don't need it. So it's used very cool here. This is very good. But we can do something more about this. See that local URL, it is composed of two things. This is basically something that is test related. It runs on localhost, right? My machine. I know that in staging, on pre-production, something like that, we will use different URL. While these things, the root and the calculate, these come from the production. Remember, I showed you early on. These come from the production code. And if somebody changes them there, I want my tests to be robust and change with them. So instead of this, I can do something like this. So I'll call this the test local URL, which is okay because it can stay here and it's going to be at the test level. And then at the setup, I concatenate the strings test local URL plus the root and the calculate. And now I'm using the URL here. And my tests become two things. First of all, it contains the constants only of those that relate to the tests. And it takes things from the production and makes them less fragile, which is okay. Okay. Next thing. These are okay. Now, I showed you the calculator params. Basically, that's the calculator params is here. Remember, this is like it's three fields, has setters and getters and blah, 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 which is okay for something with 3 arguments. But if you had like a giant JSON file or a giant data object, it will be a lot of lines of setup. And a lot of lines of setup, it's hard to see what's different between tests. And again, it makes things like very unreadable. So what we usually do is we try to create the data objects somewhere else. And one of the way to do this is to use a builder. The builder is short for a builder object using the builder pattern. Usually what it says is something like that, with first or second kind of way of a fluent interface to set up things, and then call the build, and then you get something else. Now, I know this is not very impressive, but think about this with a giant JSON files with a lot of sub branches that you can set up differently. The only difference between this test and another is one of the branches down the line with one argument, but you need to build everything else. So one of the cool things that builders do, we don't give them enough credit for that, is this. They initialize things as default, and what that means, and it's not going to be this flashy in these tests, but again, apply this for like giant data object. We can drop a lot of the setup, the common setup, and leave it to the builder, and then only have in the test what it really matters to this specific test. So again, we'll see the differences between the tests. So tests will look like this. In my case, the builder takes as a I didn't show it. The builder's default is the plus. That means in these examples, instead of having parameters, I'll call it with first and second, but not with ops. I do not send the ops. Now, you may tell me, and that is sometimes true, if I want to make things more readable, I will put the things there, because kind of hid it that the plus is the default here, but we can play with that, like call it a param builder plus, something like that, something that will tell us a lot of information about what's going in and what are the defaults. But this is an example. Take it to the value is not coming with a very small number of parameters. It's with a lot, and I worked with a very big JSON object that I loaded templates from files and added to them instead of like creating like dozens of test lines to set up objects. So the difference is that whilst it's plus, I don't tell it it's plus, but when it's different than the default, call it with ups minus. So you can see that this differentiates than the other two. Again, these are good hints for us about the difference between them. Okay, so are we done? Not really. You see, we still have two things there. So next, remember I talked about different languages in the test. We kind of separate things, but this file already talks two languages at least. One is these tests. They speak with calculator level and first and second and ops. These are like the domain language. But it has other stuff as well. It has JSON and HTTP and REST template, which are from another world, really. So we took one step. We kind of separate these things. So now these things sit in a separate function. However, the variables still stay together, kind of mix. Let's separate them. So what I did is I took this method, the call calculate, which, by the way, the name of it is part of the domain language, right? It's called calculate. However, what's going on inside it is really general purpose. So I took this body and took it to another class. I called it API call wrapper. And I moved here everything that is HTTP and JSON. So I called the method post with body because it does post for object. And it gets a URL, whatever URL it is. It gets a body, whatever the body is, because it will just squash anything to a JSON. And now I have a general purpose API call wrapper. And what's left here, sorry, that's the API call wrapper, this is before. What I'm left with is, first of all, I removed everything from HTTP and JSON to that class, so I don't have it here. Less variables. What I'm left with is something only from the domain. Setup is already smaller, and all I have is the call calculator, which is again something that is responds only for calculating under test, calls the general purpose with the URL and calc params, which is nice. Now, I would probably stop here, but I have something else to show you. Remember, I told you about user ID equals 17. So I'm going to show you an example. Apply to user to 17. I just wanted to show something that goes along with this line. So you can see in a calculator, all numbers have basically the same value, right? So you have the 3 and 4 and the 7 here have the same kind of importance as the -5, -4, and -9 here. Same for the 20 and 4 and 16, because this is a calculator and it deals with numbers. But let's assume that this 4 is special. All the numbers out there are the same thing. You can use any number anytime, but this 4 is special. How would I tell it from the tests? Well, you can do this. So I left the pluses thing the same just for reference, but look what I did here. So for the first number, which I could say could be any number, I created a constant called any number, and I use a lot of any as a prefix for things that can be replaced with other stuff. But then I use the when something is more specific. Imagine yourself any user and the admin. So you can specify different values that have some kind of meaning, not just by giving them names, but giving them some kind of, are they special? Are they specific? Or are they like general public? You can use anything. And you can use this as part of the code, and you read that and you understand, well, this could replace the any number with any other number, and I expect the same effect or behavior, not the same result. But this one, the 4, is the subtractor, is important, and it's important. Look at that, and it has kind of meaning, kind of signal up what is important. Okay, done with the code. Let's go back to the presentation. Okay, so what did we do? We refactored the tests. Obviously, do the refactoring, but everything works, right? Yeah, we took big containers of tests and squished them. We kind of separated them to their own responsibilities. One acts as part of the test class, other are service classes that help us as a general purpose, more or less. Tests are smaller. We can see like this test does this, which is opposed to this test. You can compare them. Removed the comments that didn't help us say anything interesting. Removed duplication from the names and just left there what is, again, the differentiating factor between the tests. And if it's not differentiated enough, we put more differentiation there. And we played with the constants, the literals, gave them good names, but not just that. We kind of separate them to what belongs to the test, what belongs to production code, and gave them names that signal something rather than just a regular user ID, because we can add more information by using differentiation in the names themselves. Is this special to test code? Not really. You can do these things in production code as well. The thinking about tests comes from a specific way of how we write and use tests once they fail. But cutting down code to smaller pieces, we like that. Node application, that's like programming 101. don't duplicate code, and then we go on and do it aloud. Better names, we like that. Abstractions, we like that as well. Same things we like about these things in production codes have the same meaning and basically the same effect in test code. We need to apply the same standards to both. Once we have that, we have like very clean tests. And basically that's what I wanted to show you today. So thank you very much for listening and staying. And you can ask questions now. And I will try to answer them. Either way, get in touch with me through all these ways on Twitter and whatever there is, even in the middle of the night, although I probably won't answer in the middle of the night. Thank you very much.
Hello, Gil. Welcome back on live stage. Thanks for the talk and awesome presentation. I always like it when people spice them up a bit with memes. So you ready for some questions?
Please.
Perfect. First one would be, what do you think about hierarchical test classes?
Well, that's a very good, I wouldn't even say question. It could be like a whole lot of discussion. The whole thing about test organization. How do you organize your test in classes, in suites? It's a very big way to do it. It could be like something like base classes and derived classes, which may be very useful in terms of one-time setup and cleanup, stuff like that. In clean code, basically, one of the things that we like to say is we'd like composition over inheritance. And that means you separate the common stuff into something that you use rather than inherit. But I saw a lot of, I'm seeing a lot of way that derive classes from bigger base classes. That's usually not a bad idea. Usually the problem with the hierarchy of classes in general, not in test classes, is that if you build a bigger hierarchy, then try to stick something in the middle. There's a lot of classes that inherit that kind of behavior, which leads to some, let's say, surprises. Usually I haven't seen these kind of problems in that scale on test classes. So either people don't play with that as well as with the production code, or they understand a lot better the problems around this. So test hierarchy, test organization is something that is not discussed enough and not discussed enough over time. So the only thing I think I can answer with a kind of direction is it is very important and it should be reviewed, and not once. It should be something like code that you review over time. This is something that you should review and develop as well, because this changes as well as the code changes and the test change as well. So it's a very good question, and very good that people pay attention to that.
Perfect. Thank you, Gil. Next question would be, total beginner here. Is it a good idea to start working in testing as my first dev job?
Yes. But it's not the only. I think testing gives, I'll start from the beginning. As developers, we come to testing very late in our development stages. I haven't seen a lot of people who on the first job as developers wrote tests. I taught juniors like that, but when I worked in a company, but usually that's not the first thing. And we usually, as developers, what we've been taught is to build stuff, and it will work because we build it. Why would we build something that doesn't work? We later realize that it needs testing. So testing requires like a bit of a mind shift. You need to say, well, it works if I see this, this, and this. And people who do TDD, test-driven development, actually start with this. How do I know that this will work even before I write this? So thinking like this, this looks like success and this looks like failure, is something that very important to writing, by the way, clean code. Because instead of generalizing and putting all kinds of what if cases into the code, you start with, well, this is how success looks like. If this is what it needs to do, let's build only this. And then we move on to the next thing. So I think it kind of changes your mind of how to build software. And it's not the only way to start, but I think a lot of people miss that when they're introduced to testing. And they have to relearn things. And sometimes they don't get to the point of, okay, tests may be affecting my way of coding. Because when it does happen, you write better code and safer code and more quality code. But it takes a while, and some people don't get that. They continue to write code just as before, and somebody else will test it somehow. And I think that's bad for developers.
Okay, thank you so much. Next question. Very general one. Where do you find all your knowledge?
Oh, I keep it in a box on the internet. Mostly through experience. I was fortunate enough to work in a company that the day job as developers was writing in TDD, which gave me a lot of perspective of how different it was on a day-to-day basis, not like calculator examples from the internet or sessions like this, how things apply to real code in production. And doing that and wearing a few hats from development and testing and support and product and all kinds of stuff, and speaking at conferences like this and getting great questions like this, you kind of touch a lot of different ways of how people write software and look at software and discuss software. So it has to be the answer would be experience, but it takes a lot of time, and this is why I'm old.
Yeah. Talking about your knowledge and your experience, you are self-employed now for quite some time. Maybe you want to share some insights on some pros and cons, maybe, on being self-employed as a developer.
Okay, so the pros is I don't have any bosses. But that's not really true, because I have bosses. First of all, I'm my own boss. I'm very strict. The second is that you need to go out and find customers. So it's part of the job. And it really depends on what kind of person you are. It may not seem like that, but I was a very shy person. I started talking in conferences because I knew this is kind of one way to make me make a lot of contact with people, which I didn't before, because I was a developer, just sitting in my cubicle, writing code, didn't need to talk to anyone. But I had to get out of my comfort zone, because I knew that if I wanted to own my own business, I'm going to need to do discussions on different levels other than developers. So it's a lot of pushing yourself to do all kinds of things that you probably don't like. I still don't do a lot of things that I don't like, because that's part of the business. But on the other hand, it's more flexible. I can decide what I do. I can decide what not to do. But sometimes I have to do stuff like I'll give you an example. I gave what what was it? I usually do courses and workshops around clean code and testing automation, stuff like that. And I gave a course about embedded C++. Now, I think that C++ was the first language I actually programmed in, but it was like a while ago. But this is not what I do usually. And this is what something that I didn't like to teach. And something that, as I taught it, because I don't do it a lot, I felt a bit not confident enough to pass it like I do regular stuff. So it's a lot here in your mind of what you want to do, capable of doing, and what you can do. And that's pros and cons as everything else, really. It's a higher risk, though. Yeah, the pandemic meant a lot of people didn't meet. So no more workshops. What do I do now? So it can impact anyone differently. Like someone told me, like before I became a consultant, Shamus, at least try it once in your life. Maybe you'll like it, maybe you won't like it, but it's something to try. And I think everything is worth trying once.
Every experience is worth something, I would say. Mm-hmm. Gil, thank you so much for the talk and also for sharing your personal experiences with us. Hope you have a nice rest of the day. Bye.
Bye-bye. Thank you very much.
And after this final talk, this topic day comes slowly to an end. If you're interested in some other topics, just scroll down in the live section. There you can see our whole schedule for the rest of the season. Just register there and stay tuned for it. Or maybe even if you want to have a talk of yourself, just hand in your paper on our call for papers. You find it on wearedevelopers.com/live. And if you're still looking for your dream job, go to wearedevelopers.com on our job platform. Maybe your dream job is waiting there. We have listed a lot of jobs from all over Europe, and most of them with upfront salary information. So, and the next topic day will be on October the 5th, and we will deal with Python on that day. Hope to see a lot of you there. Thank you for your participation today. Thanks for submitting so much interesting questions, and see you soon. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.